Well, hello everybody. Welcome back to yet another stream. Well, hangout, whatever. With me today, currently at least, I have only Microbloganism. Hey Micro, how are you?
Hello. I have beer because I don't need it.
Oh, you will. Unfortunately, I have to stay sober because later I'll have to drive, so yay me. Actually, no, not me.
Welcome back
This will
to
be
yet
absolutely
another
insufferable. Okay, happy Halloween by the way, everybody.
Yeah, we're showing you something really, really spooky. The scariest thing alive.
Oh yes, this is super scary. So a little
Well,
bit...
it's not entirely alive, it is brain dead.
So a little bit of backstory here. So a few days ago, I think 3 days ago, I uploaded a hangout. I streamed a hangout talking about some nonsense that our favorite chemistry bullshitters Peter and Pete spewed all across their channel, and they have since reacted to my video and to my comment that I wrote in that video on their.
Was
on
it
their channel.
only the was it the video as well? I thought it was only the comment
Well,
they really reacted to.
I think it was only the comment, but whatever, that pretty much contained everything we were talking about.
Yeah.
So who cares, basically. So yeah, they reacted to this and they made this new video called... Fuck, what was it called? And you thought that sodium oxide was real? Wrong. So yeah, prepare for a stupid one. So let's see, you should be able to see it now. The video is relatively long, but since they are switching topics somewhere in the middle, I would suggest we should just skip that part. I mean, we could do that later, just in another hangout, because for this one I want to stay with what they actually said towards my comment.
That's fair.
I think that's fair as well. Okay, so here we go. Oh, by the way, even though this video is 55 minutes long, I'll try to keep this hangout here under 3 hours if possible.
I mean, if we're only watching part of it, then that should be fine.
It's still the vast majority. It's still maybe 75% of it.
Well, then get on with it.
Yep, there we go. So everybody prepare your alcohol and keep your monitors out of punching range if possible. If not, then I'm not liable for any damages. So there we go.
Prepare your anus. Great start.
If we heat a sample of sodium metal, we see that it melts rapidly. Sodium has a lower melting point than lithium. The sodium starts to react with the oxygen in the air and burns. If we let a little bit of the smoke be drawn into the burner, we see the brilliant yellow color of the sodium flame test.
Ooh.
The white smoke that we see is actually sodium peroxide being formed.
Well, someone actually thinks that doing this demonstration shows that there's oxygen in the air. Yeah, right, okay. And I'm not thinking, but all you're witnessing is a metal melting, a metal being placed in a flame, and the metal, because it has a low melting point, it's melting, becomes a liquid, and it evaporates. Evaporates, burns
by giving, but also gives off some smoky bits,
impurities.
you know.
Stop. Okay, do you already see the problem, Micro?
I see two problems.
You see two problems.
Yeah.
Well, yeah, okay. I kind of see what you're going with, but no. So, when did I ever suggest burning the sodium? Like heating it up and everything?
Never.
Exactly, that's the point.
You specifically made it so that you wouldn't design the experiments to avoid heating, because that was one of the problems.
Oh, no sound? What the fuck? Wait a second.
No, there's sound. Other people are hearing it.
Okay, yeah, there we go. Nice confusing me, 10Z Bradshaw. Don't do that again, please. I'm watching you.
Why not? It's fun.
Keep doing it. They're doing it, so we won't have to watch it.
Good evening, Jared. How are you?
I feel human again.
What? In what way?
It's just been a long day. Nothing like coming home covered in grease because people don't know how to do their job.
Oh, I know the feel. Okay, Jared, have you had the opportunity to watch this entire video of theirs?
No. And, oh boy.
Okay, do you have beer ready?
Or whiskey, or vodka, or wine. Something with ethanol in it.
Yeah,
Or heroin.
No, I don't go that route, but I definitely have liquid insulation for this level of stupid.
Okay, how about a little chunk of lead surrounded by a copper and brass shell combined with a little bit of black powder?
Can we set it off in one of their faces?
No, sorry, I'm against animal cruelty.
Damn.
Well, hold on. It's not. They're not animals. They're vegetables.
Okay, so yeah, again, as Micro already said, I specifically suggest an experiment where heat is as small of a factor as possible, because obviously as soon as you have temperature differences, you will have to deal with expansion and contraction of gases, and that's just something that is avoidable and that is just not needed.
I have a feeling that they think that the only way to react something with oxygen is to heat it.
I do think so as well, yes. Let's continue, or do you guys have anything to add?
No.
Maybe there's carbon-based, possibly. I mean, who knows? I mean, you can see the smokiness coming off here.
Yeah.
But, yeah, I can't see how that proves oxygen's in the air at all.
No, it doesn't, does it?
Really? Yeah. I mean, if air...
You see that flame? You wouldn't get that if there wasn't oxygen in the air. Also, the person filming it would be dead.
Not only that, they accept that this chemical reaction works, otherwise they wouldn't be citing it in this case. They accept that you have pure sodium metal first, and you react it with, well, the air, and in this case they are getting a mixture of sodium peroxide and sodium oxide. So where the fuck does the oxygen come from, if not the air?
And we know they accept that they have sodium, because we know from the previous hangout we had over on Team Skeptic's channel a while back, that I don't think you can find anymore anyways. We know from that they do accept that the yellow color from the flame test indicates sodium.
Yes, that as well. I'd be very careful though, because sodium is pretty much everywhere when you're dealing with lab equipment. So whenever you're like doing flame tests, the first thing you do is actually try to remove the sodium as much as possible. Pretty much any piece of lab equipment will glow yellow first, because there's trace amounts of salt everywhere.
Well, yeah.
Just saying. You have to be careful, because you will get this sodium flame pretty much everywhere.
What's the color from the chloride?
Pretty much nothing.
Okay.
Let's continue.
So what you're saying is contamination and cleanliness and proper procedures are something that need to be considered in all lab environments?
Yes.
Huh.
Well, maybe not in biology.
Shocking.
I don't know.
Yeah. Have you heard of like infections?
God damn it! I'm just annoying you, Micro. Let's continue. Another 90 seconds.
Air is combuent and supports combustion.
You'd see the same. You'd see that.
Absolutely, you'd see the same thing.
So
happen.
reaction of sodium with oxygen.
Yeah.
So yes, again, take a look at the formula. This is exactly not a reaction that I was suggesting. They are trying to react the stuff directly, but not completely. They're not trying to burn it, and they're not trying. Well, how can I formulate this? They're not trying to produce sodium oxide. They're making sodium peroxide.
Because they're adding a lot of energy to the system by burning it.
Yes, basically. So it's not the output that you would expect when you just take sodium outside on the air and just let it react with oxygen. There is a small formation of sodium peroxide there as well, but the overwhelming majority will be sodium oxide. Around 80% of it will be sodium oxide.
Unless your room is also an oven.
Maybe then, yeah.
Don't live in ovens.
How fitting you would mention that on today.
You can be very intelligent and very good at what you do, and you can still be stupid.
Okay, we're just gonna skip the intro.
Yeah, please do.
There we go.
Yes. Well, yes, we're back again. Annoying people with our views and opinions because a lot of people,
You're
a
wrong.
lot of people really just like hearing other people's views and opinions, especially if you thought sodium oxide was real. Absolutely, of course. Or if you thought
it.
Okay, I was about to say the same thing, Micro. Okay, if sodium oxide isn't real, why the fuck is Sigma Aldrich selling it for about £1 per gram?
They should sue.
Now, granted, it's not very pure; it's only 80%, but still, it's there. I think that this is just a waste product. Whatever dirty sodium they find, they just leave out and sell the sodium oxide that forms.
Probably.
That's why the stuff is relatively cheap.
They scrape it up off the floor at the sodium factory.
So, if you're saying that sodium oxide is not real, what the fuck is Sigma Aldrich selling here?
Also, if it's not real and someone's selling it, they should sue.
Yep.
Yeah.
I mean, everybody who buys this stuff depends on it being actually what it's claimed to be. If it's another chemical, then either your reaction doesn't work, that would be the most harmless case, or you just, well, in the worst case, you die.
In the worst case, it's something really dangerous that's like you're actually buying it, it like blows up in your face.
I mean, for example, when you accidentally mix up N-butyl lithium and tert-butyl lithium, that's a fucking bad time, because one of them will burn when it comes in contact with air, and the other one will just explode.
That's just burning, but faster.
Yeah, no. I've worked with both, and it's not fun.
Yeah.
Technically, explosion is just burning really fast.
Okay, I'll give you that. Yeah, you got me. That's fine.
All right. So from the chat, I have to agree with Gertrude here. Gertrude says, I own several ingots of sodium metal. I'll happily send one to Tweedledum and Tweedledummer to play with. They can sprinkle it on their chip.
You can just send them to me. We'll come to that later.
No, what you need to do is strap it to the inside of your toilet, so that when you flush.
Oh.
That's a nice one. Actually, no, don't do that.
Also, it's a really dumb prank because the likelihood that the sides of the toilet are free of water is pretty low.
Ouch. That's a real pain in the ass.
Wait, that isn't... Oh, one way to get around that is replace the toilet with new, manually fill the tank in the back so you don't actively flush it. That way, when they use it the first time, it's the initial flush. So yes, it will be dry then.
I feel like it would be easier to just like put something, like glue it to, or like attach it to the toilet with something that shields it.
Or just dry the toilet with a hairdryer for a few minutes.
Yeah, but then you have to be seen leaning over a toilet with a hairdryer.
Okay. Okay, I get your point. Let's continue.
that maybe burning sodium metal in air proves that there's, or demonstrates that there is oxygen in the air.
Yeah.
Whoa, hold up. Did they just admit that there is oxygen in the air when the last video they were trying to say
no,
wasn't?
I think they're saying hypothetically.
They're trying to say what quote unquote the mainstream explanation is. also known as the actual explanation.
So they're trying to screw it up. All right.
Yeah, what did you expect? Of course they're screwing it up.
I can't understand why people say that. Though that proves that there's oxygen in the air.
Absolutely, of course.
And they come out with all these formulas of this is the reaction, like we saw in that video just a minute ago. But that's just theoretical.
Stop! Ugh. Okay, this comment regarding the formula is theoretical. I work with chemicals every fucking day at work.
I mean, technically everyone does.
Yeah, okay, fine. Well, yeah, okay. I actually rely on chemical formulas, on stoichiometry to work.
Yeah.
I rely on it to predict the amounts of chemicals that are necessary for my experiment. I rely on the quantities that I get to be accurate to a certain degree, because otherwise I just either waste materials or it would just be dangerous or expensive or whatever. The entire chemical industry relies on chemical formulas to work. Not only do combustion engines, for example, mix air and fuel in the ratio to make the combustion as efficient as possible, but also half of the Earth's population relies on, for example, the Haber-Bosch process to actually live, because otherwise we wouldn't have enough fertilizers for everybody to, well, feed on. So
anyone who takes pretty much any kind of medication.
Yes, basically all of modern, well, a big part of modern science and all of modern chemistry is based on the fact that chemical formulas and stoichiometry work. So if you think that's wrong or that's fake or whatever, you have a giant fucking mountain to climb.
Also, it's not even like I don't understand how they think like formulas, like abstract descriptions of what's going on, how they're theoretical. That's not what theoretical means. Like,
Jared, anything to add from your side?
It basically what it boils down to is, well, it's essentially just math, and math isn't real, math isn't reality, ergo chemistry is wrong.
I wonder.
That is what I see as their attempted logical path.
Yeah, I wonder what they would think of cell signaling diagrams. Are they fake too? Are they only theoretical? What about a map over the London tube system? Does that mean the tube system is theoretical?
What about the periodic table? What about nuclide maps, for example?
Haven't they actually addressed the periodic table before?
Yes, they have. There's they renamed it to something like the periodic table of like product or something. Products. And I also found a comment of someone suggesting, some other idiot, suggesting that, they should do their own periodic table. And, well, they basically said, we've thought about that. So they might come a video where they make their own periodic table.
Oh, that's gonna be painful. That's gonna be the chemistry equivalent of Riley's thesis, but worse.
That's gonna be chemistry 9/11.
Ouch. Well, moving on then.
Just theoretical, absolutely, of course, yeah.
You got to prove that there's oxygen in the air.
Absolutely, of course, yeah. Well, I was talking to somebody today and they were telling me about fish breathing oxygen.
Oh, yeah.
And in the back of my mind, I'm thinking, but how can a fish breathe when it doesn't have lungs?
Oh, well, yeah.
Okay, Micro, time for your rant.
Fish breathe using gills. It's like you don't need lungs. Also, you don't even need lungs to breathe air. Like, there are frogs that pretty much have, their lungs are very underdeveloped and they just breathe through their skin.
Yeah, that's why in But that's why amphibians have moist skin, right? Because it's easier for the oxygen to diffuse into the skin when
Well,
it's...
well, most of them have. Well, not all amphibians.
yeah, okay, most of them.
But like no, there are like very small frogs that have very underdeveloped lungs, where they will even get the oxygen from the air on land.
Nice.
Like this is like elementary school biology. This is so fucking simple.
Yeah, but I think they don't even understand what an element is.
Of course they don't. I'm surprised they're able to turn on their computer.
So for example, how can we, well, measure or show what sodium actually reacts with when you let it out to air? For example, by the simple methodology called gravimetrics. Basically, we take a known amount in terms of mass of sodium metal, and we let it react, and then we measure the mass of it again.
Well,
and,
wait.
Yeah, okay, wait, whatever.
Unless you're using a mass spec, in which case it's a bit hard.
And from that, we can pretty much determine with what it reacted and how it reacted. So that's a rather easy way to find that out. Just one example.
Oh, for another good example of something that doesn't breathe using lungs, there are turtles that breathe through their ass.
Okay, that's a piece of information I never wanted to hear.
So they go into hibernation and they
Stop.
sort of like go underwater.
Stop,
Don't
continue, please.
They have these two sacs connected to their cloaca. Well, just inside it, where it's full of blood vessels, and they will pump their water in and out.
I don't.
Get oxygen for
Okay,
that
okay,
way.
moving on.
Most fish don't have lungs.
So what you're saying is Riley has a nephew.
God damn it.
What I'm saying is turtles probably have really bad breath.
How can, if oxygen's a gas, which everyone knows oxygen to be a gas, how can that exist in water?
Stop.
Oxygen is only a gas at like Earth pressure and temperatures.
Yeah, you go away from that. It can be a liquid. It can be a solid. I mean, it's almost like elements have multiple stages of energy that actually change its physical state.
Well, you're both missing the broader picture here. They don't understand that gases can actually be dissolved in liquids.
Well, I understand that that's what they're fucking missing, because that's how fish breathe.
Not only that, that's how your fucking sparkly seltzer water works.
I mean, technically, that's also how we breathe.
Well, technically, I suppose so, yes.
If you couldn't dissolve the oxygen in water, it wouldn't be able to go from inside your lungs to inside your blood vessels.
I mean, by the same logic, right? Sodium chloride is a solid. How can it be dissolved in a liquid if it is itself a solid? It's the same exact stupid fucking argument. And it would work if it was correct. But it's not, you fucking idiots. Ding.
Oh, Piperate in the chat. No, they don't think water is H2O. So that's stupid.
Yeah, real quick, they think electrolysis isn't valid because you can't perform it with the voltage you get out of the socket in your wall.
Yeah, because you have to they claim that because you have to have higher voltage to force it through. That it's not wrong.
Actually, that's not completely correct. They're saying you cannot do this with distilled water, which is kind of correct because there the voltage is more relevant than the amperage, but you actually don't need the voltage out of a socket to do electrolysis. A car battery will do just fine. It's just important that you get direct current, but they still don't accept it for whatever reason. Poor guys. Moving on then.
Oh yeah.
Well, actually,
Bo
in our internal chat brings up a good example. Wood lice, or pillbugs, or whatever you want to call it, they don't have, because they're crustaceans, but they live on land, they don't have lungs. They actually breathe with gills on land. They just keep them moist.
You mean those little 14-legged fucker thingies? The ones that can roll up?
Well, some of them can roll.
Yes,
roll up.
obviously some of them, yes.
Yes.
What lies?
Yeah.
Okay. Moving on.
I can't understand how a gas can even dissolve in water.
No.
Well, that's your
maybe
problem,
if
isn't
the gas changes to become a liquid and then is saturated into the liquid, into water as a liquid, then I can understand.
Yeah, that would make sense.
That would make sense for it to happen.
So yeah, again, the same stupid argument. They don't understand that something can be dissolved without changing its state. So again, I'm pretty sure that they accept that there's salt in seawater, sodium chloride and a bunch of sodium iodide and a bunch of other stuff. And yet, sodium chloride is a solid at room temperature. By the same logic they're using here, it should not be possible to dissolve sodium chloride in seawater.
Well, and some people in the chat are already mentioning it, and we've mentioned it as well. And my question is, how the hell would they explain carbonation in soft drinks?
Yeah, they can't. Moving on. Let's actually do this in 90 seconds increments if possible, okay?
Sorry.
But
Like
how
carbon
can,
dioxide, for example.
but it's like, but you can't liquefy oxygen
At room
and
temperature.
then at room temperature and think that it can dissolve in water.
Yeah, absolutely, yeah.
Because liquid oxygen only exists at a very low temperature. So there's something. But I allowed her to carry on with her spiel.
Dream.
Oh right. Yeah.
I didn't.
Stop. Okay, this is not a spiel or anything. Nobody's ever claiming that oxygen gas dissolves in water because it liquefies first. That's just a straw man. And that just shows how fucking idiots or how fucking ignorant you guys are. I mean, seriously, what the hell?
It's amazing. Like, it's amazing these two people can get through like their day-to-day life.
I mean, I've brought this example up in the last live stream when I was talking about degassing. Whenever I do a reaction with something that is reactive or that reacts with water, that does not react with water, but that reacts with oxygen, I make sure that the water that I'm using when I need it is degassed, which means that all the oxygen that is dissolved in it is removed first. And the easiest way to do so is just to bubble pure nitrogen through it. And that works. And I rely on it. And again, it works. Why does it work? Do you have any explanations for this?
Well, yeah, they have to have in their quote unquote, with many quotes, model, they have to explain why bubbling nitrogen through it changes what happens when you put the thing in the water.
Yeah, but they can't explain anything. That's their problem.
Exactly.
Whatever they're proposing so far has no predictive powers whatsoever.
Didn't really want to. I endured and suffered the
Well, it means that she can talk
the
about
BS.
She can talk about BS rather than talk about what's important in her life, because that's what it's all for.
Absolutely,
It's
of course,
to fill up one's head.
fill up one's head. Anyway, what have we got on for everyone's?
Yeah, a little bit of oxygen in your brain would maybe be good for you guys. I'm just saying.
It's long. That is long past. Your brain can only really survive so long without oxygen.
Do you have to ruin my joke every single time I make it?
Yes, that's my job.
Oh, I forgot.
Today, Peter.
Well, for everyone's pleasure, we're going to revisit the last video, because the young girl who sat beside the doctor, the Indian doctor, asked a very poignant question which we overlooked, which we need to emphasise. So we'll
Have a look at that.
Yeah, and also from that video, we got some comments that made us think about the flame, and the flame having pressure,
and well, the necessity of pressure. In order for a flame to exist.
So we're going to have a look at that. We've got this, and you thought sodium oxide was real.
Absolutely. Well, it's our opinion that that opinion is wrong.
Well, we think it's a pseudo substance.
Well, we think it's a pseudo substance. Yeah.
What do they fucking mean by pseudo substance?
I don't know. Also, I'm curious. Like, they said that it has something to do with the pressure. The pressure, like, correct me if I'm wrong, but isn't the pressure, it's atmospheric pressure. It's an open container.
Yes, the pressure doesn't really change in the flame. The only thing that changes is the density of the gas that's, being heated up. Which is why you have convective currents.
That's why the water gets pushed out. But, like, it's not like there isn't, like, if the pressure actually rose in there, well, for that to happen, you would have to have the water not be pushed out.
Yes, exactly. In the experiment that they were shown, last time, so the fact that the two containers are connected with water, which can move, shows that both pressures inside the container, inside the vessel, and outside are identical, all the time.
So the pressure it's pointed to talk about pressure. Like, the pressure of the flame, like, not even that it actually has anything to do with anything, but it's still just, like, it's not even wrong, it's just irrelevant.
Moving on.
Of course, yes.
But this is a result of...
It's theoretical substance.
A theoretical substance. No, it's not. I've worked with fucking sodium metal, right? I used it a few semesters ago in, I think in an organic lab course, where I was preparing sodium methanolate. Basically, all you do, you take sodium metal and you throw inside methanol. So basically, you can deprotonate the methanol and use that as a strong base for deprotonations for some organic reactions. And I did not use all of it. And the easiest way to just dispose of sodium that you don't need is just to let it sit on air until it's oxidized, which takes 5, maybe 10 minutes, something like that, depending obviously on the size of the chunk.
Just throw it out.
Not throw it out. Basically, we just throw it into a container of water, because at that point, all the sodium metal itself is gone, so it's completely harmless. The only thing that happens is that there's an acid-base reaction going on between the sodium oxide and the water. So basically, you get sodium hydroxide solution from that, and that's pretty much harmless. So yes, I've worked with this stuff. It's absolutely fucking real. And that's actually a challenge. If you think it's false, then explain what the fuck I worked with.
This is a result of a hangout we did with Team Skeptic many moons ago, in which a person was on that hangout.
Was on the hangout.
And who...
Say my name. I mean, that person, that is obviously me.
Well, yeah.
So they sometimes try not to mention my name, which is kind of hilarious. I don't know why they're doing that. It's just weird. I'm not a demon or something. I won't show up if you say my name 3 times in the mirror. Not yet.
Who's left a comment for us recently.
Absolutely, of course.
And we're going to sort of cover that. Yeah, we're going to cover that.
And we're
going to have a look at some information about magnetism. Ferromagnetism.
Absolutely.
Because I put forward a view that the only thing that has an affinity with magnetism is iron. Iron is the only thing that has an affinity with magnetism.
Okay, so should we do this magnetic stuff as well, or should we skip over it?
That's up to you.
That's a whole nother ball of wax. I'm more interested to see what they have to say about your comment.
Okay, so the next 20 minutes or so will be basically purely about magnetism. and them not understanding what first of all, not understanding what magnetism is. Then, second of all, not simply denying that other materials than iron can be ferromagnetic. Just one example, which I mentioned in the lengthy comment I wrote. For example, when you take a look at the €1 coin, the core of it, so it's made out of 5 parts in total, and the part in the center, in the inner ring of it, or the inner, coin, that's made out of the core, that's made of 3 layers. And the piece in the middle, that's actually pure nickel. And the reason why that is simple, because the ferromagnetic properties of it are used by, vending machines, for example, that can detect whether a coin is, whether it's a real coin or whether it's counterfeit. So that's just one example of something that does not contain any iron whatsoever, and its ferromagnetic properties being used for real-world applications. So yeah, you're just full of shit. Okay, so they continue talking about my point at about the 24-minute mark. So let's just skip there if that's fine. Let's say 23:50. That should do. And yeah, they also continue talking a little bit about fire, but pretty much this has nothing to do with my comment. Everybody ready?
No, but go on.
Hang on, let me finish chugging the first drink.
Chug.
Yeah, again, it's a shame that I can't drink today because I will have to drive later. Oh, wait a second.
It's not that you can't drink, it's that you shouldn't.
That is kind of true.
And Frank Vellante has it right, Gio. You're a crazy kraut, not a demon.
Seriously, you're making the pun about crazy kraut, but you're letting out the Deutsche Dämon? Why am I better at making jokes like this than you are?
So when do we get to the Nazi?
Oh god. And there's something about N. Whatever. Okay, so 24 minutes, let's go.
Yeah.
Makes sense.
Okay,
Well, even they say in this, it's very similar to blowing out a candle.
Very similar to blowing out a candle. Absolutely, of
So
course.
you're applying a greater pressure to that flame.
Absolutely. So it's got nothing to do with oxygen.
I love how the audience is apparently so stupid that they have to mime what blowing out a candle is.
Somebody joined.
Yeah, that was Rumpus.
Hey, hello.
Hello, Rumpus. Can you today hear Peter and Pete finally?
I can hear you clearly. That's not a step forward. And I think I can hear them clearly. I'm not, obviously you've stopped it, but I can hear you clearly, which is a step forward.
Okay, because I found a way to actually increase the volume to such a degree that at least Micro could say or confirm that they are at least as loud as I am. Or close to it.
Just play it again quickly so I can check.
Yeah, we'll continue anyway.
All right. Okay,
So-
well, I can hear you clearly and you're not breaking up. So that's a huge step forward.
Okay, do you have anything to add so far, Rumpus? To anything that was played until now?
So I haven't been watching, I'm afraid. Sorry.
Okay, that's not too bad because the real stupidity is gonna come in the next few minutes.
God.
So. Yeah, if you have any beer or other alcohols or preferably hard liquor available, I suggest taking that in right now.
Damn, I've got it. I'm just out at the moment. I've only got. I was going to go out and get some, though. I felt I had to go and do something else. But damn, no. So no, I haven't got any ready. It's going to endanger my health. Then. Oh well, okay, never mind. I'll go with it. I'll take the risk.
You'll take the risk. Okay.
Yeah.
Then let's continue.
Is it really? When you think about it,
No.
why the flames are there.
Yeah,
It's
it's
more
got
to do with pressure rather than oxygen. Well, that's the way I see it, by looking at this.
Well,
you know.
yeah.
Anyway, so that's that one. And I think we are now on
Our main segment.
The new thought, sodium oxide was real. Now, we've come across sodium oxide a while ago. And we was a little bit about this because, but I'm sure we can safely say now that in our opinion, sodium oxide is a pseudo substance.
Yeah. Well, let's go on Wikipedia, shall we?
It doesn't really exist, sodium oxide.
Let's go on Wikipedia. Here we go.
Sodium oxide, here we go. Now, sodium oxide is a chemical compound with a form
If it doesn't exist, why does it have a Wikipedia page?
I do not know. And apparently they don't understand the contradiction either.
It's just part of the conspiracy, man.
Oh, right.
Formula Na2O. It is used in ceramics and glasses, though not in a raw form.
Oh,
That's because there is no sodium oxide. That's why.
Yeah.
Stop! What this article is describing is that glasses do not contain pure sodium oxide. Just read the article. It is, I think it's saying it further down. They'll come to it. I'll read it then.
It is the base and hydride of sodium hydroxide.
So they
So
dry
when-
it out.
They have no idea what the fucking anhydride is, and they don't know what sodium hydroxide is.
They obviously think that because, like, they obviously interpret the word anhydride to mean that you remove the water.
Well, that's actually basically what it means.
Well, but no. I mean, that's kind of what it means, but not exactly what it means. Like, there is an actual, like, you can make an anhydride without involving drying out.
Yes, that's correct. But anhydride basically means that it's a substance which has a water molecule removed. That's basically all it's saying. It does not mean that the synthesis route must work by removing that. You can do other reactions as well to get that.
Yes, exactly. That was my point. But they obviously think it means drying out only.
So they dry it out, yeah. So when water is added to sodium oxide, NaOH, is produced sodium hydroxide. Na2O plus H2O goes to 2NaOH.
So you dry out the sodium hydroxide, which
Stop! That's exactly not what this reaction formula that they're currently hovering their cursor over is describing. In fact, it's the exact opposite. You can do it. You can dry out sodium hydroxide to get sodium oxide. Perfectly valid. That's actually a rather simple test on how to differentiate hydroxides from oxides by just heating them up. If you see water condensing, let's just say you put some of it in a small test flask and you heat it up. If you see condensing water on the top of the flask, it's likely hydroxide. Because you basically removed the water molecule in the sodium hydroxide, the one H2O unit that you can dry out of there. That's one way. But this is exactly the opposite reaction of what is happening right here. It's the other way around.
Hence why it says when water is added to.
Rumpus, do you have anything to add?
It's no good. It's all breaking up for me, I'm afraid. Again, I can't really hear what's going on, so I think I'm going to have to give it another miss.
God damn it. So it's
I mean,
definitely
I
your
mean-
internet connection. It's not something over here, because apparently the other people can hear me
Yeah, I
and
can
them
hear it
just
fine.
fine.
It is breaking up rather than a volume issue now. Are you using a Discord app on the desktop, or are you using a browser to go into Discord?
I'm using the Discord app, the standard Windows 10
The
Discord
desktop.
program. Yes.
Yeah, well, yeah. For me, it's just breaking. It's like it's going through some crackle, like trying to hear it through some sort of cereal that's got some water, milk poured over it. So unfortunately, it's just.
That's
Yeah.
odd.
Okay,
But
I think you need to maybe
you're not
reinstall your
breaking
audio
up now.
drivers or something. Well, okay,
Possibly.
let's just try to continue. If you happen to hear anything clearly, then just say so and just add your comments.
Yeah.
will give you your sodium oxide.
Yeah, basically that's what they do. But that's not technically correct, though, is it, on forming a true oxide?
No, not really.
No, it's a bit of a cheapskate, really.
What's
what-
a false oxide?
Yeah, in what way is this not valid? This is just one way of multiple to get sodium oxide. You can do it this way by taking sodium hydroxide and just heating it up, basically, removing the water. But what you can also do is, and the article will describe this later, just take sodium and let it react with air. Or if you want directly with 100% oxygen. That's also valid. There's no reason not to do this.
Sodium anhydride is with nitrogen, isn't it? Sodium nitride.
Yeah, we're not talking about sodium nitride. We're talking about sodium oxide and sodium hydroxide here.
Okay, sorry, I thought you mentioned it earlier. I thought it was that.
No, we were talking about anhydrides.
Right, anhydrides, but they are nitrogen compounds.
No. Anhydride, just take a look at the formula in the middle. Do you see that?
Which is what, sodium oxide plus water?
Yes, exactly. And turn that formula basically around. Well, you can by heating sodium hydroxide up, you can remove one water molecule via this formula.
That's what
that's basically what anhydride means.
That's why it's called anhydride, without hide.
Right. Sorry. Okay.
There's multiple compounds of this class. For example, acetic acid anhydride is a very often used base chemical.
Yeah, this is right. That's always interested me actually. The why is the oxygen there? Presume it is the oxygen that's hungry for some more. Hasn't it? But why is that? Why is the oxygen? Presume it's the oxygen. It's not. I mean, they both see. I thought in sodium oxide, everything would be really happy. The sodium's got its.
No. The reason is oxide is relatively. It's unhappy in the way that the ion is, or that the atom itself is relatively small, but it has to carry a relatively high charge. In this case, 2 electrons more than it should have. And that's not a really energetically favorable state. It's better to just have a proton attached to it, with which it can share 2 of those electrons. That's better in terms of energy. And this is why oxides are many oxides are very strong bases.
Right.
For example,
they really want those hydrogens.
Yeah, not the hydrogens, only the protons, only the nucleus of the hydrogen atom.
That's the same thing in my book.
So yeah, for example, the alkaline metals or their oxides, those are very, very basic.
Yes, indeed. This has always surprised me. I've always thought they'd be very happy.
No, there are a bunch of other oxides. For example, iron oxide is relatively stable. First of all, the crystal rust. Yes, the crystal lattice is better because the packing of the atoms is better, but also the iron cations actually attract some of the charge in the oxygen atoms.
Right, I must admit, this has always confused me. So, okay, well, I won't stop your thing, but I'm going to go investigate this more because I still don't fully. So you think it's an ion packing? It's an ion packing issue.
For example, yeah, there are multiple factors that influence this, but packing is one of them.
Okay.
One reason, for example, why aluminum oxide is so energy poor. For example, why the thermite reaction works is that the crystal lattice energy in aluminum oxide is very low.
Right.
So this is a factor that you have to factor in those reactions.
And what's sodium oxide? Is it not? Oh God, what's the packing form of the best packing form? It's called close cylinder.
That depends actually on the different ion radii.
Yeah, exactly. So what the one that's the best one, the most stable one? What's that called? Off complete. Yeah. Close packet. I can't remember how it's called now.
It's called cubic densest packing, I think, in English.
No, it's not that. Okay,
then the hexagonal one.
Is it hexagonal?
Yes, hexagonal densest packaging or whatever it's called in English. I don't know.
Okay, well, yeah, well, don't let me stop you anyway, because I think I'm probably going to have to give up in the end anyway. So
don't worry, it's fine. Okay, so let's continue. There's still 30 minutes of stupidity.
Oh my God. Oh, Jesus.
And the alkali metal oxides, M2O, M equals the crystallised in the anti-fluorite structure in this most positions of the anions catalysed. Why is all that stuff there?
But let's look at the information.
It's there because it's
just go through the whole description, the whole document here.
Okay. Stop.
Because it's relevant.
Can you do me a favor, Micro, and read Wait a second. You won't be able to see this, damn. I just read it. So this is the Wikipedia article that they are citing. It's the exact same page in English and everything. Exact same article. Sodium oxide is produced by the reaction of sodium with sodium hydroxide, sodium peroxide, or sodium nitrate. Then there are the three formula. Most of these reactions rely on the reduction of something by sodium, whether it's hydroxide, peroxide, or nitrate. Completely okay. And then burning sodium in air will produce sodium oxide and about 20% sodium peroxide. And keep that one in mind and keep that sentence in mind because they are going to do something with it.
Oh, sorry, right, the whole glass making.
Oh, let's just go
references. And that's it. That's all we got.
That's all we got. All the information.
You'll get the great stuff is sodium oxide is produced by the reaction of sodium with sodium hydroxide, sodium peroxide, or sodium nitrate. Okay, but when you have magnesium oxide, do you not just heat up or combust magnesium?
Stop. Okay, who notices the problem here?
Well, I mean, they're talking about sodium, like, I'm not sure why they're talking about, like, why it's so relevant that, like, you can make them, that's how they're made usually when you make a lot of it. Like, when you actually have a factory making it.
Oh, no, you missed part of what they said. They immediately switched to a different elemental base.
Yes,
well,
Jared got it.
Yeah.
Jared noticed it. So the problem
I
is...
noticed that too.
Yeah, so magnesium is not an alkaline metal, it's an alkaline earth metal, and those are different in terms of their reactivity. Magnesium is somewhat stable at air, but if you heat it up, it will completely oxidize with a very bright flame. But yeah, again, magnesium is somewhat stable, you can actually just handle it in your hand. It's not gonna burn or anything, it's not gonna decompose. It's not going to heat up or anything, it's more or less stable. So, false equivalence. Do they understand that not nitrogen, sorry. Sodium behaves differently than magnesium? I don't think so.
No. The answer is always no. You ask them whether or not they think. No, they don't.
You know what? You are probably right.
Not probably. I know I am.
Wait a second, let me just reorganize something here on my screens. There we go. Okay. Let's continue.
Yeah. To get magnesium oxide.
Yeah. Well, the trouble is, is that when you heat up sodium, because it has such a low melting point, it just doesn't turn into an oxide.
Stop! You don't need to heat up sodium. It reacts at room temperature. That's why it's so dangerous to handle.
Wait, and would you classify 1.1 thousand centigrade as a low boiling point?
No.
Because I have the page pulled up as well, just for comedic value, and they said, oh, sodium has such a low boiling point. I look over and see, melting and boiling point. So the melting point is 1,132 degrees centigrade.
That's rather typical for a metal.
Yeah.
So nothing extraordinary there.
The boiling point is 1,950 degrees centigrade.
Which is, by the way, a temperature you're not gonna reach with a simple Bunsen burner. Just saying. So if they're saying
that's just a matter of burning the right thing in it.
Yeah, if they're saying that the experiment that they showed in the beginning was just an evaporation of it, no, it wasn't. The vapor pressure at the maybe 1200 degrees, if the Bunsen burners really said, well, 1200 approximately, under ideal conditions, maybe. But again, the vapor pressure is so fucking low that no, you're not gonna evaporate your sodium. No fucking chance.
Also, I mean, for fuck's sake, when you actually, like, it's gonna react because it takes time to heat up. It's gonna react with the oxygen before it starts like just evaporating.
Yes, yes. I'm giving them the benefit of the doubt here. There's no evaporation happening whatsoever.
Yeah.
So the way to try this, for example, would just to repeat the experiment in a nitrogen atmosphere. Or just to be sure, because I don't know how sodium reacts with nitrogen at very high temperatures, just in an argon atmosphere, because there I can guarantee you nothing is gonna happen.
I don't think anything would happen in a nitrogen atmosphere.
Yeah, I'd be careful. At very high temperatures, weird things happen.
True.
So yeah, again, just make sure and go for a noble gas, because those
I'm
won't
curious.
do anything.
If you heat it up. If you heat it up, yeah, it's got a melting point. What's it? Melting point of
90 degrees, isn't it?
no,
Or
it's
just
not.
over 100.
Melting point. It's there. Look. 1132
Oh,
degrees centigrade. How is that possible?
No,
oh, this is
that's
sodium
sodium
oxide.
oxide.
Do apologise. I'm
Not
talking about sodium.
metal.
Sodium metal, of course. Yes.
Mm.
Sodium metal.
But you wanted the other examples of glass making, didn't you?
Oh yeah, sorry, yeah, of
Yeah.
course, yeah. So we've done that. No, wait there, yeah. So most of these rely on the reduction of something by sodium. So, sorry, in preparation, most of these reactions rely on the reduction of something by.
Oh, I thought they were talking about the sodium itself. My bad. So sodium oxide has a very high melting point. That's not to be expected. The boiling point and melting points of sodium are gonna be lower. Do you understand my confusion?
Mm-hmm. It still doesn't matter.
Yeah, no. Because the
Yeah.
again the boiling point of sodium is gonna be very much higher. Let me guess, like
800.
900 degrees maybe?
Just under 882 centigrade.
Yeah, again, the reaction with air is gonna happen way before that. So yeah, again, my argument still stands. Try evaporating sodium with the Bunsen burner.
Whether it is hydroxide, peroxide, or nitrite,
Yeah.
sodium is always attached to something. It doesn't come in its raw form.
And all they do is
Stop! And then the next fucking sentence says, burning sodium in air will produce sodium oxide and about 20% sodium peroxide.
It's literally on their screen.
Yes, so they're ignoring the sentence that says that sodium itself can be used to produce sodium oxide. I mean, seriously, does this count as a quote mine? In my opinion, yes.
Yeah, and an avoidance of reality.
So it's both quote mining and cherry picking.
Yes, I agree. Well, more cherry picking than quote mining, I guess.
They're mining cherries.
So yes, they quote one sentence, but they completely leave out the next one that describes where they are wrong. And I don't think they're gonna continue talking about this one sentence, the one that's relevant. But we'll see.
just heat it up.
Burning sodium
Sorry, there we go. Okay.
in air will produce Na2O and about 20% sodium peroxide, Na2O2. So blah 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 blah.
Yeah,
And
blah,
glass
blah 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 blah. So they are actively at least trying to ignore that one. I mean, seriously, what the fuck?
Shocking.
So they said before that sodium itself is quote always attached to something, and now they have this formula that shows that pure sodium metal can be used to produce the stuff, yet they just shrug it completely off. I mean, seriously, what the fuck?
They're idiots.
Oops, there we go.
making. Here are a few of the applications. Sodium oxide is a significant component of glasses and windows, although it is added in the form of soda, sodium carbonate.
Oh, right.
Oh, right, okay.
Okay.
Sodium,
sodium oxide is not a significant component of
No.
glasses.
No.
absolutely, sodium.
No, it's because it's a lot easier to get hold of sodium carbonate.
Yes, but this is called calcination reaction. When you heat up carbonates, you actually can remove one CO2 molecule from the carbonate ion.
Well, yeah, it decomposes.
Basically, yeah. And what is left in this case is sodium oxide.
Yeah, I was going to say, so because you can
And
use one sodium compound to result in another during a reaction, it's not real? I don't follow.
Also, guess how you make glass. Oh wait, you heat it up.
Carbonate. Sodium oxide does not explicitly exist in glasses, since glasses are complex cross-linked polymers. I'm trying to work this one out.
Can you start seeing this information and understand where we're coming from in that?
So because it doesn't explicitly exist in one place, it doesn't exist at all.
Apparently. Also, this Wikipedia article is kind of a little bit weirdly phrased because I wouldn't call a glass a polymer. It's amorphic.
It's not. Glass is not a polymer. That's just plain out wrong.
Yep.
Cross-linked polymers, that's plastics.
I think
No. That's actually fine, Micro, in that regard, because there are crosslinks in glass. It's not individual long silicon dioxide strains. The problem is just that polymer kind of implies that there's regularity to.
That's what I meant.
To it, which in glass there is not.
Hang on, guys. They're talking about glasses like what's currently on my face, not what you put in a window.
That doesn't make a difference. The glasses you have on your face are still not polymers, unless they're made out of plexiglass.
Yeah, and Micro, you do realize that most eyeglasses, that is the joke that Jared is making, are made of plexiglass.
Really?
Yes.
Yes.
They are highly transparent polymers because they are much lighter and thinner.
And yeah, exactly. And also the way you can actually get some of the advanced features like your optical correctness and also the blue tint for specifically working with computer screens like the glasses I wear. You can only do that if you're using the plexiglass type polymer based technology. You can't do it with true optical glass.
Oh, I learned something. Cool.
Yep. So basically, the higher your dioptrion value is, the higher the probability is that you get plastic glasses, because glasses would just get too heavy.
But that is not the kind of glass they're talking about.
No, obviously this is not. We're just again giving them the benefit of the doubt here and trying to make some sort of point.
It's a pseudo compound.
It's a pseudo substance. Sodium oxide is a significant component of glasses and windows. Okay, although it is added in the form of soda, sodium carbonate. Sodium oxide does not explicitly exist in glasses. I can't reconcile those two pieces of information.
Yeah, because again, they don't know how stoichiometry works.
Also, it says they do not explicitly exist. That there's they don't understand English.
Again, you could have stopped it. They don't understand.
Fair point.
They're very confusing. Typically, manufactured glass contains around 15% sodium oxide.
Yeah, but the trouble is that.
But then they're saying sodium oxide does exist in glass.
Yeah, because you know what? What they're saying is that the sodium carbonate is added to the glass, which is then heated.
To form the sodium oxide.
What they would say is sodium oxide.
Yeah, I know, yeah. It's a cheap way of getting around it.
What they would say, so they accept that when you heat up sodium carbonate,
it decomposes.
And you might get two different products. I mean, do they understand, or do they accept that carbon dioxide is produced in this?
No idea.
It kind of suggests that they do, but then what else would be the remaining other product other than sodium oxide?
Yep. Like trying to predict what they think about a topic they haven't, even topics they have explicitly said things about, is like impossible.
Essentially use sodium carbonate.
Absolutely.
Yeah, the sodium carbonate soda serves as a flux to lower the temperature at which the silica melts. Yeah, soda glass has a much lower melting temperature than pure silica.
That's why it's
and
used.
It has slightly higher elasticity.
So it's in ways in which they could save money on the fuel costs.
On the fuel costs, absolutely, of course. They've been using sodium carbonate for years in glass making.
Yeah,
of course. So now this came about because we had a comment from a person who...
Say my name. Why do they keep doing that? That's so weird.
No, you're just a person.
They're afraid to butcher it.
Well, they will
probably
butcher
will.
it. But I'm not necessarily mad at them for that because everybody butchers it.
We came across on Team Skeptic.
Team Skeptic, yeah. Because in our last video, we asked at the end of the video.
First of all, stop this entire team. Well, let's continue. You'll see it in a few seconds.
If you're watching out here, show us a demonstration that shows that there's oxygen in the air.
Absolutely, of course. And Geo Straber, who's Straber.
I like the fact how they pronounce it somewhat correctly in the beginning and then correct it and make it worse.
Yeah, they tried to go more German and...
That's just at the side here, so...
Who's at the Team Skeptic farce, really.
In what way is this a farce? First of all, Team Skeptic was neither involved in this hangout that we just did 2 or 3 days ago. He wasn't there. Second of all, how the fuck does it matter who I associate with? How the fuck is the list of my friends relevant to the arguments I'm making? I think they're trying. They're trying an ad hominem fallacy here. That's all they're trying to do. They're trying to refute the argument that I'm making by not talking about the argument itself, but just by trying to attack me.
Also, the only reason that thing was a farce was because they behaved like fucking children.
That's true. Third of all, I don't think that they understand that I'm not just some random layman here. I actually am a chemist. How do they not get that?
Yeah, absolutely.
There's a long list of reasons why they don't get that.
Probably reduce brain cell
Really
count.
long reason. There's the reason.
It says, you want to do an experiment where the combustion product being a gas and the large temperature differences won't influence the accuracy of the result.
Well,
okay.
I'm assuming he's relating that first sentence to the candle demonstration.
Yes, of course I'm relating it to the candle demonstration.
That's a question you asked, you fucking idiot.
Because that was the topic of your entire last video.
Someone ding me.
Someone what?
I said fucking idiot. Someone ding me.
Oh, ding.
Thanks.
To the candle demonstration, absolutely, of course. Repeat the experiment using sodium metal as the fuel.
Trouble is with that is that you need you got to have the water to show the displacement.
Stop. You don't necessarily need water. Any fluid will do. Which
you don't
is
even
why...
need fluid.
Yeah,
but you could just have like a piston.
You could, but if you want to repeat this experiment as closely as possible to what they showed and what they did, then this liquid method, the method of the rising water level, that's perfectly valid.
Yeah.
Just for security reasons, I would switch out water with another liquid that just does not want to, or that does not react whatsoever with sodium.
Because things like accidentally exploding would be bad.
Yep. It's not only the stuff exploding itself, but remember what forms in that reaction.
I mean, that's just an argument for them actually trying it.
I mean, think about it. Let's just say they tried this experiment with sodium, right? And with water.
And they knock something over.
No. So they have this probably glass measuring cylinder upside down with the sodium in it, not touching the water, and it reacting with the oxygen. Then they might knock it over, the sodium falling in the water. Then you would get a buildup of hydrogen gas in that glass cylinder. And what do you think would happen if they were to pull it out and there was a little bit of a spark there with oxygen rushing in?
Again, you're just making an argument for them trying it.
Yeah, no. So, as laymen, don't do this. Don't do this. And if you do this, talk to somebody professional who knows how to do this stuff, and be especially careful about safety precautions. Because this stuff is actually dangerous. Alkaline metals are not a joke.
Absolutely, of course. Yeah, repeat the experiment using sodium metal as a fuel. Okay. It reacts with oxygen quite neatly, completely and quickly without producing any gaseous combustion products that influence the amount of gas inside your test cylinder. But did we not see that in this demonstration that it was giving off some smoke?
Yeah,
smoke,
but
yes.
he never said to set it on fire, you two fucking moron.
Okay, so this entire smoke thing. So there's two different things here. First of all, the guy in the video says that the smoke that is produced is sodium peroxide. It's kind of right, but it's not the entire story, because when you take a look at the flame that they were using, it was set rather, well, oxygen poorly. So when you set a Bunsen burner this way, you always get a little bit of, well, not completely burned up residues, also known as soot.
Because it's an incomplete reaction.
Yeah, but basically you get little pieces of carbon that just form everywhere, because they, again, don't burn all the way, don't oxidize all the way to carbon dioxide. And I wouldn't be surprised if this was a little bit of a factor here as well. Just saying.
Off some smoky kind of fumes there.
Well, it's
Let's
the
have a little look.
impurities.
There, you've got the impurities coming off, So we've got that. Yeah, sure. Got to get back on his comment there. Repeat the experiment using sodium metal as a fuel. It reacts with oxygen quite nicely. Blah 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 blah. Also, the reaction happens at very low temperatures, which means that the gas inside the glass containers won't be heated up as much as when the candles are used.
But you're still going to introduce it where there's water.
Again, you don't necessarily need to do it with water.
Also, we're not putting it inside the water.
Yeah, I specifically mentioned in my comment, they will show this later, that I specifically say that they should make sure that the stuff does not get into direct contact with water. Because first of all, it would falsify the results of the experiment. Because obviously you want the sodium only to react with oxygen. And second of all, it's dangerous. Especially for somebody who does, or who has not worked with, well, chemicals at all, I guess, whatsoever before.
Absolutely, of course. So sodium metal. Let's have a little look.
So
at this.
he's not really telling us a really good way of doing this.
Boiling
goes
point,
on to do
where's its
that.
melting point. There we go. 97 degrees centigrade.
Yeah.
97.794 degrees centigrade.
Okay.
That's the melting
We're
point.
not melting it.
Yeah. Again, the boiling and the melting points are completely irrelevant. The oxidation of the sodium metal itself with oxygen happens again at room temperature. I said that before, and I guess I'll have to say it again. You don't need to heat this stuff up. Micro, your turn.
No, you don't need to heat it up. That's all that needs to be said here. They're morons.
sodium metal, according to this Wikipedia page.
And sodium metal really doesn't like water.
It really doesn't like water. It reacts violently to water. But anyway,
You're not putting it in the water.
Because water breaks down. Just
Yes, water breaks it down, but air also breaks it down, just in a different way.
like lithium metal and potassium.
Yay, so they understand that the alkaline metals are very reactive because they have one more electron than they would like to have. So, well, at least that's something, I guess.
I guess.
All the other alkali earth metals.
Absolutely, of course. Calcium as well. All the.
Did he just say calcium as well? I gotta go back.
I've missed that, sorry.
All the other earth metals.
Absolutely, of course. Calcium as well.
All the alkali earth.
Not all the alkaline earth metals react this violently with water or with air. Magnesium should even be stable under water. Calcium,
Also,
I don't know, maybe.
Also, what does calcium have to do with it? We're talking about sodium.
Yes,
Those
we're talking about
calcium and sodium are pretty fucking different.
Exactly, we're talking about alkaline metals, not alkaline earth metals. Again, different chemistry, different properties. Why do they keep trying to change the topic away from alkaline metals? And we're talking about main group 1 here. Main group 1, also known as, well, the alkaline metals.
Well, they're trying to deflect from the actual point because they are trying to say, well, this one metal reacts this way, why don't they all? Forgetting that different elements have different reactivities to different substances.
Yeah, but how can you forget this? Gold is a metal too, and so is mercury and lead and fucking copper.
It's not forgetting. It is direct, willful feigning of ignorance. Because keep in mind, every time little dipshit there on the right takes a drink, what is he taking a drink from?
Piece of glass.
A mug with their own visage on it.
Oh, you mean yes, you're right. I completely forgot about that. Well, I guess Pete is drinking from a glass. He's drinking orange juice or something, and Peter is drinking something out of the Peter mug.
Probably tea.
I don't know. Coffee, meth.
Well, you don't drink meth. You smoke it.
Well, I think you could. Couldn't you?
You can
eat.
You can eat meth, but like you get more out of it by smoking it.
How do you know?
Because I've looked things up.
Okay, let's continue. You realize I couldn't make a joke about your teeth implants, right?
What? You cut out.
You realize that I couldn't make a meth joke about your tooth implants.
Well, no, it's not so much about that. It's more a question. I thought Gio was the chemist, not Micro.
Yeah, but I'm just teasing him.
Okay, wait. I'm confused. How can you make a meth joke? Oh, because you lose your teeth. Okay.
Yeah, there we go.
Metals have been man-made.
Absolutely, of course. Blah, blah, blah. Do not let the sodium react with the water directly. First of all, it's a rather violent reaction, so it's dangerous, and I can't recommend doing that as a layman. Second of all, it would falsify all results you would obtain. So tell us something we don't already know.
No, absolutely.
Make sure the sodium metal only reacts with the air.
We can tell you a lot of things you don't already know.
But how do you want it to react with the air?
Yeah, I know, yeah.
By just taking it out of its container. Sodium, again, is stored usually under oil because it doesn't react with the oil. However, as soon as you take it out, it will start oxidizing. It will change its color from shiny metal gray, first of all, to white. Well, to like not shiny gray and then to white. And then it will start to fall apart as a white powder. So the only or the simplest way to react a sodium metal away using air is just to take it out of its packaging. That is all. By the way, you can also that's something I just want to say. When you actually receive sodium in metal form, usually there is a small layer of oxide on it. But the way you can remove it is quite simple. Just take the cubicles or whatever and just cut them apart. Sodium is very soft. You can actually cut it with a knife. And if
Just
you do
rub
that,
it. Just rub it.
that would work too. Just cut it apart, and you will see the shiny metal surface on the inside.
Don't actually rub it. That's a way to get burns. It will react with the moisture on your fingers.
I understand, but I just don't think that your joke is funny.
No, do you want us to burn it? Is that what you want us to do?
No.
Well, burn it.
No, I specifically said not to do this.
I don't know.
jar.
I think he's saying because it says gases, because he's talking combustion here.
No, it's
Saying
not.
combustion. Where
Combustion product is perfectly fine.
Yeah, they think that combustion means there's fire, rather than combustion as in it's a reaction between something and oxygen in the atmosphere.
Yep.
the combustion product. So
Why doesn't he do it?
I don't know.
First of all, look at that face. If you want, I can do it. It's no problem whatsoever. Buying the stuff is relatively easy. I think I could do it for a budget of maybe $50. It's not hard to do.
Bucks being what?
Euros.
Currency? Okay.
Euros
Yeah.
or maybe pounds, I don't know. But sub $100 definitely.
Yes.
Because everything basically that I need is one Erlenmeyer flask, one cork stopper thingy, about 2 meters of, transparent tubing, one measuring cylinder, the sodium,
Why does it have to be 2 meters?
because I want a little bit of a distance between your measuring cylinder and the sodium.
Fair enough.
Just in case they actually want me to use water, I don't want to have the risk of those two substances getting in contact. And what did I miss? Yeah, the water itself.
And
That's
some
it.
sodium, obviously.
That's what I said already.
Okay.
So yeah, it's not hard to do. If you want, I can even live stream this shit.
That would be interesting, but there is one other thing you missed. It looks like Peter there is in the process of degassing.
Make
As
sure
long
that
as it doesn't follow through.
sodium can be bought at pharmacies or even online.
Yeah, I know, yeah,
Just be
yeah,
safe
yeah.
and make sure that the sodium does not get into contact
know,
with
yeah,
water.
yeah.
The reaction of sodium with water produces highly flammable and partially explosive hydrogen gas, according to the following reaction formula. 2Na plus H2O goes to H2 plus Na2O.
No.
The reaction you want is the direct oxidation of sodium with oxygen, according to the following formula.
So why don't you just leave the sodium in the air then?
Yeah, exactly. That's what I'm saying. Just leave the sodium in the air. At least Peter seems to be understanding it.
Well, one of the things I'd like to mention, and that is when we look at the preparation here, why can we not get sodium oxide just from heating it up with oxygen?
Stop.
Because you're adding in it, you will get that, but you're adding in will get the peroxide.
Okay, so this is actually the part I thought they were talking about earlier. So this time they will actually ignore the second paragraph. Take a look at that.
Or with alleged oxygen in the air?
Well, let's play that
Just
video.
by burning it.
Yeah, let's play that video again at the beginning.
There, this one here.
Yeah, so this should be sodium
Here we go.
oxide.
This should be sodium oxide. What's in his small little ladle?
Yeah, come on.
So did you notice that they ignored the second paragraph?
Yep.
Shocking.
He's got a little piece of sodium which he's burning, so it should turn into sodium oxide.
Yeah.
That's what we should expect to see. Okay. So there's the sodium. It's melting. It's becoming a liquid.
Yes. Yeah, it's liquid.
But it's not turning into a powder, is it?
You're burning it.
Oh. Ow. That level of stupid just hurts because, yeah, if they actually read what you said is just let it react with air, and what happens?
But-
Exactly that. You get sodium oxide, which is the white film, white powderishly film that forms on the outside. You scrape it off, give it a little time, and you get more.
Yep. So I actually found a video of somebody demonstrating this. Yep. So let me share this to you. Obviously, I won't play the video. Sorry, I won't play the sound. At least to you guys, because it's just not necessary.
Okay, so what else can the sodium react with in air? So if we cut sodium, we should be able to see...
Okay, so he's currently preparing the sodium. He just took it out of its container. You can see that here. This is basically the sodium pellets or cubes. You can see some of them here being stored in a liquid. Presumably I would use something like silicone oil if I had the choice.
That's probably what it is.
Okay, so he took one of them out. And as you can see, it's already a little bit stained. It's not shiny metal gray. It's more like whitish grayish. So
it has the dull appearance.
Exactly. It has this little piece of oxide layer on it. So what he's doing is he's taking it and he's cutting it apart. Again, this is very easy. You can just cut it with a knife, almost like butter.
And now it's all ready.
Yes, and now you can see that you have this very shiny metal surface on the inside, which is not yet stained.
Metallic butter.
Yep. But already...
Look.
Did you see that?
Watch it happening.
Yes.
That freaking quick, guys.
Let me play that again. So here it's dark gray, and look what happens within a matter of seconds. The metallic shine is completely gone. Well, almost completely gone.
It's like the majority of it disappeared. He has to angle it so actually.
Yep. But you can see instantly that it's changing its color. And if you wait long enough for this piece, maybe 15-20 minutes, it's rather large, it will fall apart completely.
So is it that the oxygen can actually penetrate it, or is it just that when it reacts, it falls apart and the rest of the structure, leaving room for the oxygen to be able to get into the rest?
It literally falls apart.
Okay.
Yeah, it breaks apart as a result of the reaction. It's a type of corrosion that you deal with a lot of times when you're using aluminum fittings too.
Yes, aluminum is rather...
Yeah, except aluminum, it actually sticks. So you get why aluminum
exactly.
stays.
In aluminum, this oxide layer on top is actually rather stable, which is why the stuff doesn't corrode away. Yeah. In sodium, it's not stable. There's literally a powdery surface on it that just falls off as soon as you shake it a little bit. So...
Shake that sodium.
This entire block will react after a certain time. You just have to give it some time to do it.
No, it's just kind of like burning, really. Yeah. Now it's burning. We can see the flame starting.
Yeah,
yellow.
It's under inside a fire.
But there's no white powder.
Of course, there's no white powder when it's fucking molten.
Composing, isn't it?
It's decomposing by the heat. It's kind of like
evaporating.
Evaporating, yeah. Now, could that be why you can't get
gas
sodium
and evaporating
oxide?
is not the same thing.
Yeah, because if we were to go on...
What's the point in doing what he's telling us to do?
Because that's not what he's telling you to do, you two idiots.
Yeah, absolutely, yeah. If we get...
Yeah, again, why magnesium oxide?
Because it's the only other oxide they know. Or something.
On magnesium oxide.
Apparently they know a lot about white powders.
Are you talking cocaine?
I thought you were going to say a lot about white liquids.
Well, they're showing the powder on the screen and they keep going back to.
Yeah, that's a pile that would make Scarface very proud.
Okay.
Until he finds out that it's magnesium oxide.
We've even got a picture of it.
Let's have a little video.
Magnesium oxide is actually rather harmless.
No. I think Scarface would be very disappointed.
Yeah, okay, I get it. Magnesium oxide, do you know when you watch the Olympics, the stuff that those, what are they called? Let me look the name up. Gymnasts, The white powder that gymnasts
the
put on
powder.
their hands before actually doing one of their stunts.
The talc powder.
Yeah, talk.
That's actually magnesium oxide.
Oh.
Yep.
Fascinating.
Final formula, magnesium oxide. Here we go. Burning magnesium. Let's go on magnesium oxide here. Let's just... we don't want that. The empirical formula of magnesium oxide. Here we go. Let's have a little watch of this. So there we go.
How long is it?
That's too long.
Too long.
Wait there, let's have a little look. All we have with magnesium is, to make magnesium oxide, is that you get magnesium ribbon, what he's got there, and put it in a crucible, small little crucible. You weigh it. Well, this is what these people are doing anyway.
What these people are doing. So he's using a gravimetry here. Basically, if you know how much magnesium you used, you can kind of derive how well it reacted and with what it reacted by just comparing the masses of the starting materials and the products.
Wait, so you mean you can actually do a ratio of the expected yield and the actual yield?
Yep. You can quantify the stuff. This is something that they cannot do, and that's their big problem.
Okay, you weigh it, pop it in there, and then you get apply some heat with a Bunsen burner. Oh, wait there, let's go back. Wait there, I've got to... Here we go, let's switch this on. I don't want people to miss out the burning bit. Otherwise, they might think it hasn't burned. There you go, got the flame on it now. Okay, there we go. Got the flame.
Oh, there we go.
There we go. Got so there's the flames on it. The magnesium ribbon. It should get to a point where it starts to get so hot that it will glow very white.
That's not a glow. As soon as you see... So the combustion or the burning of magnesium actually produces this very, very, very bright white light.
It's used in fireworks for that reason.
It's used in fireworks, for example. Do not look at it. You will actually damage your eyes. Just saying.
Look at it. Stare at it.
Yeah. There we go. We've got a bit there. Look.
Oh, wow.
You can see it's glowing there. And
Take
it will
this
eventually...
time,
all
innit?
there
So
it is.
that is not on fire yet. That is only glowing because of the heat.
It's black body radiation at this
Basically,
point.
black body radiation, yes.
There it is. Wait there. After this little clip, it will move to overhead. There we go.
Now it's on fucking fire.
Hence why it's just like white.
Yes. Basically, this. If you've ever seen it, the stuff is so bright. It's hard to film it, actually, as you can see, because it just oversaturates any camera sensor. It's not a yellowish white. It's like a really, really white, I guess. And there's no chance extinguishing this. The only thing you can do is cover it with sand and keep your distance.
And hope for the best.
Basically, yes.
We can see that it's glowing very brightly there.
Yeah.
And essentially what's happening is,
The latter one was not glow. That was literally a magnesium fire.
It's still glowing.
Yeah, but glowing implies that it's just because of heat. This fire is literally caused directly by the chemical reaction.
That's just a lot of glow.
Yeah.
instance, people would say that it's oxidizing. Okay.
Well, yeah, it's
Simple
on
as that.
fire.
Yep. Yes.
Basically, what's happening is you're seeing calcination.
Yeah, basically, yeah.
I think they mean calcination.
I have no idea. But, like, I'm not even sure what word they said. It was just noises.
Okay, so a calcination reaction is... we actually talked about this earlier in glassware when you had, for example, sodium carbonate.
Mm-hmm.
And you heat it up and you get sodium oxide because
so it's something
carbonate
removing
itself.
carbon dioxide. It's something removing carbon dioxide.
Basically, yes. This is actually a very important reaction to make cement. In this case, it's not using sodium, it's using calcium. So calcium carbonate needs to be calcinated to get calcium oxide, which is then used as a starting material or as an ingredient for most cements. But that's not the only example. For example, calcinations also, for example, reactions where you have crystal lattices that contain water, for example, bauxite and gypsum. If you heat those up and you remove water from them, that also counts as a calcination.
Would using baking powder in a cake count as one?
That's actually possible.
Because, I mean, the way baking powder works is you have sodium bicarbonate that then breaks down and releases CO2.
Yeah, but I'm not sure whether that's caused by heat or whether there's a chemical reaction going on.
No, it's heat.
It's only the heat, are you sure?
Yeah, it's a decomposition.
Yeah,
I'm almost positive.
But again, a decomposition can also be caused by, for example, acid in this case.
I'm almost certain that using baking powder is literally just it breaking down, it gets heated up.
I don't think so, but I'm not sure.
Let's see.
Let's continue in the meantime.
It's expanding due to the heat, and it's absorbing the air surrounding that's being what's the word? Sucked into the
imbued.
It's being imbued by the surrounding air. Yeah. So the air is being sucked into the lid of, through the crucible lid, blah blah blah, and it's being absorbed into the magnesium, and it's turning white.
But it's slightly different to that sodium. What was happening to
Absolutely,
the sodium?
of course. Let's just do this.
Let's see him tip out his
crucible. There you go. Now you can clearly see what's happened there.
So yeah, that is basically completely burnt.
Okay, I was wrong. It's actually because there is a weak acid mixed in with the baking powder.
Yep, that's what I said.
Okay, I always thought it was just because you heated it up.
No, I think you actually need higher temperatures to do this.
Probably.
I mean, what temperature are we talking in oven? Like 250 degrees maximum? You need at least
something like that.
500, 600, 700 degrees to actually do this. At least for carbon dioxide. Or carbonates in general.
Well, maybe both reactions could be taking place and the acid is there to speed it up.
No, I don't think so.
Oh, he's putting water on that.
He's putting water on it.
Yeah, you can tell.
Or he's breaking it up, actually.
Yeah.
I think the white stuff there is magnesium oxide.
Oh, okay, so they accept that magnesium oxide is a thing, but sodium oxide isn't?
Bicarbonate starts decomposing when heated over 50 degrees Celsius.
Bicarbonates.
Sodium bicarbonate. That's what's in baking powder.
No, that's sodium hydrogen carbonate.
No.
Yeah. Pretty sure that it's sodium hydrogen carbonate.
It's a mixture of carbonate and bicarbonate.
Okay, so we're actually both right to a certain degree. So, yes. And it is a sodium hydrogen carbonate. So it can both decompose under heat, but it can also react with weak acids. Yep. So for example, two units of sodium hydrogen carbonate can turn into 1 unit of sodium bicarbonate, 1 CO2 and 1 H2O. So that's a decomposition reaction, and the reaction with an acid would just be 1 unit of sodium hydrogen carbonate plus 1 proton would turn into 1 water, 1 CO2 and 1 sodium plus.
Well, yeah. It's a bit like calcium.
It's exactly the same as calcium oxide when we look at the
calcination process.
Calcination process. Here we go. calcination process. When we look at let's have a look. What should we have? Calcination, making calcium oxide. Here we go.
Oh, right, yeah, there you go.
Let's have a little look. See if we can quickly have a look at.
Okay, why the fuck are they talking about calcination reactions now? So far, none of the reactions that I propose was a calcination reaction.
They're talking about it because they are idiotic enough and yet intelligent enough to stay away from the point you actually made.
This is another oxide, isn't it?
This is another oxide.
This is mainstream's understanding of an oxide, not ours.
Absolutely, it's cool.
Yes, mainstream understanding, which has practical applications in science that your lives depend on. For example,
they don't know that.
The fact that you probably live in a building that contains some sort of concrete, that alone shows how necessary and how important this process is for us.
So you've got the heat, and you've got, I don't know what he's got there. What's he got there?
He's got a thermometer.
Has he got a thermometer
Digital thermometer.
Just 55. I don't know what he's got in the saucepan.
Don't know.
Oh, so you didn't actually watch the video?
Flame to that as well.
Great.
Of course not.
Well,
why would they do legitimate research? I mean, you have seen them before, right?
Okay, so my prediction is they just have some calcium carbonate in that crucible thing and they just heat it up. If you heat it up enough, you will decompose the carbonate ions and you will end up with calcium oxide.
So you get it. I'm sure there's lumps of calcium in there.
Calcium, yeah.
That's probably what
Chalk.
he's got in there.
That is the
Or something
cutest little
very
tiny
similar
pot.
in his little didgeridoo, and you can clearly see that he need more heat.
Yeah, you will do.
Because with calcium you need about 1100 degrees centigrade.
Yeah.
So he's now got a improved super duper kiln.
Heat source. There you go.
Here's the
Why are
heat
we
source.
talking
You can
about
see that's
calcium?
glowing. Look at that.
Glowing.
So he's had to put the camera down before the lens melts, and I don't know what that is.
Is that what he's...
I think that's what it is.
He probably
Well,
says
it's
it.
in-
Yeah,
Probably
I was gonna
should have
say,
used
if you
pottery
actually
as my
listened to
vessel.
the video, you would probably know.
Yep.
But no, they are actively towing the line between giving the appearance of having looked into this stuff and avoiding the actual information in totality.
Yes, for example, the value that they gave out for the temperature that is needed, 1100 degrees, they definitely looked that up beforehand.
Yeah. Also, judging by what the preview little thing, I think what we're seeing here is the leftovers from the vessel he used.
Yes, I was about to say maybe that pot thing they used wasn't actually designed for those temperatures.
That's why it says probably should have used pottery as my vessel, because that would have.
So yeah, if you heat up your cooking materials, in this case, this pot thingy, they're not designed for 500 degrees. They're not designed for 1000 degrees. They will just get fucked, and their surface will get attacked by those temperatures and just, splinter off like this. Or chip off like this, or whatever the correct phrasing is for this.
Pottery.
Anyway,
but the whole point of it is that, there. I think it's not.
Yeah, that's it.
Is that it there? The white stuff.
Yeah.
Yep.
The white
Look at that. That thing is completely destroyed.
stuff.
Yeah, maybe that's why you should use the proper tools and the proper material for doing this type of stuff.
Typing.
Yes.
There is.
Yeah, you can see some chips here have gone missing. So, Micro, you're probably right. That is what we saw.
He hasn't got much there.
He hasn't got much there. He didn't do a very good job, did he?
No.
Oh, there you go. Look, he's poured it out there. This is the stuff I made earlier, or I bought from the shop.
Oh, right, yeah, there you go.
Calcium
oxide.
Calcium oxide.
Notice the white powdery colour.
The white powdery colour. Now that
texture.
Absolutely. Now that Oh, because that's his lump of. That could be his lump of calcium there, is it?
Now, is he going to react it with water just to show people?
No, I don't think he is. No, that's fine.
No, so there you go.
There you go. Yeah,
This
absolutely.
is the mainstream's understanding of calcium oxide.
Calcium oxide, absolutely. Yeah.
Now let's go back.
You heat up limestone calcium carbonate to produce calcium oxide. Magnesium oxide. You heat up magnesium, and it will produce magnesium oxide.
Yes, but this is not a calcination reaction. Do they understand that those are two different chemical things?
Obviously not.
I mean, they seem to understand it because Pete here said that you get magnesium oxide from starting with pure magnesium and heating it up, which is just burning it with oxygen.
Yes.
So he does understand that you can do the synthesis route starting from metallic magnesium. And yet he doesn't think that this is possible for sodium.
Apparently not. But like, I think the main point here is that they really, really, really think that because you have to burn the other things, because you have to burn magnesium and calcium, that you also then necessarily have to burn sodium.
Without understanding that magnesium and calcium are alkaline earth metals which react much less quickly with air.
Yeah.
And that actually needs to be heated up to react with air, at least magnesium. I've never worked with calcium metal, so I actually don't know. By the way, magnesium metal is used in a organic reaction called grignard reaction, which is kind of interesting because you produce a compound that contains a bond between magnesium and carbon.
Mm.
Yep, so if you need carbon with a negative charge, you do a Grignard reaction. You can also do it with lithium, but that's a little bit weirder.
Now, I wonder what they would have to say about the fact that a large number of performance motorcycle engines have a lot of magnesium components to them.
Why is that? Only because of the weight reduction?
Yep, weight reduction.
Fun fact, some laptops are actually made out of magnesium aluminum alloys.
Yes, my old laptop was made out of that. That is why it got the name magnesium.
My tablet is as well, my Surface. They're made out of magnesium alloys as well.
Yeah.
I mean, it doesn't make that much of a difference, let's be honest here.
No. That's how the naming trend of all my electronics named after.
You're breaking up there, Micro.
That's how the naming trend of me naming all my electronics after elements.
Oh!
That started.
Oh, okay, that's cool. Let's continue.
Now let's have a look at sodium metal again.
Let's have a look at sodium metal again. So here we go. Here's the reaction of sodium with oxygen.
Right, so watch that white powder. Look out for
Okay,
that
here we
white
go.
Powder.
Yeah, look out for that white powder. So let's have a look. Reaction of sodium with oxygen. Okay.
Each
So
time they
he's
said
heating
that,
it
I
up.
couldn't help but think of drugs are bad.
So yeah, again, you guys are absolute.
You have to look out for the white part.
You guys are absolute idiots, Pete and Peter. I'm talking to you. You guys don't understand that I'm not suggesting doing this.
Oh, there it is. There's sodium metal, and it's melted. We've got a liquid now.
No reason to melt it whatsoever in the experiment I'm suggesting. None.
Melted at 97 degrees centigrade.
Absolutely, which is less than water. The boiling point is water. And we've still got the liquid. The liquid's burning now, so we're not seeing a white powder form at all.
No,
and it's just glowing.
And
it's giving off a lot of smoke and fumes, and it's probably just disappearing.
Yeah, I'd imagine. Yeah.
Isn't it?
Disappearing where?
No, it's disappearing. It's not there anymore, so it has to be disappeared.
It will probably disappear.
And there's nothing left. So how on earth you can actually have sodium oxide is beyond me.
Yeah, absolutely.
How you can have sodium oxide? That's quite easy. You can just
You take some sodium and you take some oxide and you put it together.
No,
And
Michael, you can't see that yet, but I put up the web page from Sigma Aldrich again, where you can just order it if you need it. So yeah, 80% sodium oxide, 250 grams for 217 British poundings.
What is the last 20%?
Probably sodium peroxide, I guess.
Okay.
Because as I said, this is probably some sort of waste chemical that they just need to sell for some price.
Yeah, that's fine.
Because probably selling it is cheaper than disposing it, even if they sell it at a loss. Because,
do you think the reason they don't believe in oxygen is because if they denied its existence, they don't have to live with the fact that there's oxygen thieves?
That's why I'm calling them Oxy-Morons.
Yeah, wow, yeah, I got that joke. I think everyone got that joke.
Yes.
Absolutely. So when we do look at this page here, it does make you think whether sodium oxide is a pseudo element and does.
Element!
No one's claiming it's an element.
Nobody ever claimed sodium oxide is an element. Sodium is an element. Element just means that all the atoms that you find in that element have the same number of protons. If you have a substance and you want to find out whether it's an element or not, just see whether you can find out whether the amount of protons in the individual atoms differ. If they're all identical, it's an element. If they are not, it's something else. It could be a salt, for example, as sodium oxide is. It could be an organic molecule, as for example ethanol is, which I would really like to consume right now. Or, for example, whether it's a non-homoatomic heteroatomic gas, for example, something like carbon monoxide, which you guys obviously have been exposed to. But it's not an element.
No, it's not carbon monoxide. It's lead.
Oh yeah.
So,
Lead's an element as well.
We have a related but unrelated announcement. Apparently, Jeranism is on the front page of Reddit. Under the subreddit, watch people die inside.
Oh, that's just perfect.
The tagline, Flat Earther mistakenly proves the Earth is round.
Oh, that took surprisingly long to blow up. How long has this video been up? 1 year almost?
You know what that is? It's interesting. Sorry, had to make it.
Okay, 13 more minutes. Let's get this over with.
Or pseudo substance, and doesn't exist at all.
Okay, so at least he corrected himself and said pseudo substance. That does not make that any better.
No, saying he corrected himself knows there's a difference.
Well, here's my question. If it doesn't exist at all, how would someone like you, Gio, be able to work in your field?
Not at all.
That's what I thought.
So yeah, again,
it's a conspiracy, man.
The fact that we actually don't blow ourselves up regularly. The fact that we can work relatively safely with all the chemicals we use is directly dependent on our knowledge of chemistry. Which means that if anything would be wildly inaccurate, as they are claiming, we would be fucked. I mean, not only in research labs, but think about what would happen in large-scale chemical plants. I mean, there are enough accidents already, right? But think about if there was something completely wrong about our understanding of chemistry.
Yeah, I grew up within a reasonable distance of one, that if that was the case, that shit would have blown up decades ago.
I mean, don't take me wrong, there are sometimes there are big chemical accidents. My favorite example is
those accidents. Those accidents don't happen because chemistry is fundamentally, as we know it, is fundamentally wrong.
Yes.
It's because someone fucks up the safety.
Basically, it's mostly because somebody fucks up the safety. For example, there was an explosion in a, I think it was a fertilizer factory. Well, not only fertilizer, but also explosive factory in Ludwigshafen in, I think, 1911?
I had no idea.
Yeah, sometime in the early 20th century. And they made ammonium nitrate, which is not only used as a fertilizer, it can also be used as an explosive. And the problem was that
fertilizer bombs exist.
Yes, and the stuff basically solidified inside some of the pipes in that plant. So one thing they would regularly do to get those pipes free was to use dynamite and just blow them free.
Oh my god.
This is not as unsafe as you think, apparently, because it has worked dozens, if not hundreds of times.
I like the fact that they just have dynamite lying around.
I guess they probably bought it just for that purpose. But the main thing here is, one time it didn't work. And give me a second. So that was so it was in 21st of September 1921. I'm putting it on screen right now. Take a look at that crater. You guys have to wait a few seconds. So, let's see. About 200 tons of ammonium nitrate in Oppau were stored in a building, blah, blah, blah. During a shift change, there was a big explosion. It killed 561 people. More than 2,000 were injured. In the small village of Oppau, almost all buildings were destroyed or damaged. The entire area around Ludwigshafen, up to Mannheim and on the other side of the Rhine, was heavily damaged. People were killed by collapsing buildings. And 25 kilometers away in Heidelberg, roofs were destroyed. A tram derailed. And in the Cathedral of Worms, all medieval windows smashed.
Oh no.
And in an 80-kilometer radius, many windows were broken.
This is fucking insane.
The explosion could be heard. It could even be heard in Munich, which is 300 kilometers away.
Does it say how many megatons it was roughly equivalent to?
I don't know, but I wouldn't be surprised if it was the same size as a small nuclear device. I mean, I'm talking a few hundred tons of TNT equivalent at least.
Yeah, I mean, it's a very, like, there's a lot of it. It's a baking, so...
Scale of the explosion, it's on the English Wikipedia article. Let's see. Okay. From the 4,500 tons of fertilizer, apparently only 10% exploded.
That's something.
So it could have been much worse. So if you ever work in a chemical plant that makes ammonium sulfate and ammonium nitrate fertilizer, don't clean the pipes with dynamite.
Oh, 1 to 2 kilotons. Okay, thank you.
2 kilotons. What was the size of the nuclear device that was blown up in Hiroshima? Wasn't that like 4.5 or 5 kilotons?
In what? You cut out?
In Hiroshima.
No idea.
Let's see. Atomic bombing. Let's see. I'll just Google the name of the bomb. It's easier.
Little boy.
Okay, it was 15 kilotons.
Yeah, but still, for an industrial accident to be that energetic of a reaction, here's something to think about. So, what was the distance from the plant to where they were still able to...
300.
300 kilometers.
300 kilometers, so...
So approximately 190 miles.
So, yeah, 190 miles. I grew up 14 miles away from a refinery that was owned and operated by Dow Chem.
Correct me if I'm wrong, but wasn't there a similar explosion a few years ago in the USA?
Not in my area.
I think there was one. Let me check. Yes, 17th of April 2013 in Texas, 29 kilometers north of Waco. Basically the exact same thing that happened in Oppo. So giant amounts of fertilizer exploded.
Yeah, down that way I knew of that one, but not up in my area. So where I'm at in New England, a lot of that heavy industrial stuff has been moved out.
Okay, so this one was caused apparently by something different. There were... Let's see. Yeah, it was just somebody not reporting the actually stored amounts of the ingredients, and therefore the safety precautions not being done correctly. So they basically underestimated how much material they had actually in storage. And the response in terms of safety was not made accordingly.
Whoops.
Yep.
But again, it blew up because someone fucked up the safety, not because that's because chemistry doesn't work the way it actually works.
Okay, so the crater that was left in that one had a diameter of 28 meters and destroyed 142 houses completely. 300 houses and vehicles were damaged.
On the plus side, because it's an explosion, presumably it spread all the fertilizer all around it. So presumably it actually helped the agricultural in the area.
At Harry Warp, no, that was not the Texas City explosion. There was actually a third one also in Texas in 1947. And it also killed about 560 people, so the same as in Oppo.
The best industrial action.
And it was also ammonium nitrate. Yeah, okay, what do you expect? I mean, it's a fertilizer, so it's really required in gigantuan amounts. Let's continue. We've been stuck here for a while.
Absolutely. Because I can't see how you can get this. If they do palm off a product as being sodium oxide, then it's likely to have been like sodium hydroxide.
Hydroxide that's been heated up. So that the water's left, if you know what I mean. The water's been evaporated.
It's probably what's happened.
The
sodium hydroxide has been leached and then it's been dried.
Okay, so in what way does drying sodium hydroxide to the point where you actually let it react to sodium oxide not give you sodium oxide?
Apparently, it doesn't, because you can only make it, in their mind, you can only make it like that, it doesn't exist. They're essentially claiming that, but you have to heat this other thing up to make it, so the thing you get isn't a real thing. In what world does the world work like that?
It doesn't.
Exactly.
And it's been dried. Yeah, that's
heat.
why the preparation of sodium oxide is produced by the reaction of sodium with sodium hydroxide.
Or as the one on the bottom, I can show you again.
Oxygen.
Let me just read that one again, because I don't think they show it again. Burning sodium in air will produce sodium oxide and about 20% sodium peroxide.
Or sodium peroxide or sodium nitrite. It's just that the latter part can be altered so that you're just left with your sodium oxide. Technically.
Did they just say sodium nitrite or nitrite?
I don't know.
Because nitrites with a D are just N3 minus. They contain N3 minus ion, while nitrites with TE in the end contain a NO2 anion as the one that's shown on screen right now, right there. That's nitrite.
Why do you have to have two different things that have almost the same name?
I don't know how that historically developed.
That is really stupid.
I know it's kind of unfortunate, yes. Okay, going on.
Yeah. So getting back to
It's not a true oxide,
Yeah.
is it?
So
Because it
getting-
hasn't been heated.
yeah. So
It's not a true oxide because it hasn't been heated.
Yeah,
In
as
what-
I said,
That's a non sequitur. Something not being heated, therefore not being an oxide. Those two things have nothing to do with each other.
it doesn't. Never mind.
getting back to
Too high temperatures. It hasn't been halogenated.
absolutely. So getting back to geostriebel.
Wait, halogenated? Where did they get halogens from in this?
From nowhere.
Stop it! They haven't mentioned a single halogen. What? What the fuck?
Geoschreiber's comment. So here we go. Yeah, sodium oxide is a very alkaline white powder.
Wow.
So make sure not to inhale it. Right, okay, but
Okay.
you show me some sodium oxide, please. You know,
Absolutely.
Oh,
if you need.
wait a second. So, there we go. Satisfied? Probably not, but I don't care.
I don't want them to be satisfied. That's gross. They don't deserve it.
Need any advice on how to perform this experiment safely, you can reach me either by
I'm just
answering
trying
this
to-
comment or by messaging me on blah 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 blah.
But I'm just trying
You know,
to,
thanks ever so much for the offer, but we don't feel that we need to do that at all.
because I'm trying to figure out how that proves that there's oxygen in the air.
Yeah, I can't, you know, because when we do actually what
Because again, the experiments you showed last time are not perfect to measure the amount of oxygen or the oxygen content in the air, which is why I'm suggesting you repeat it the proper way.
Like it can only react like in order to get a compound that is literally has the word oxide in it, you kind of need oxygen.
Yep.
Like if okay, fair enough. Let's say that that's not the reaction that happens. Then what is the reaction? Because clearly it's changing. Something is happening.
Yeah, so far we haven't gotten any explanation on what could cause this if it wasn't the reaction I'm describing.
Well, because that reaction apparently doesn't exist.
demonstration, you know,
Yeah.
of course we've got to play it again because we've got to ask you, the viewer, as well.
Yeah.
Does this prove that there's oxygen in the air?
Yes,
This
there's
demonstration
a
here.
fucking flame.
Does this prove that oxygen is in the air?
air.
A constituent of the air, 21%. How does this prove?
Yeah.
If you think it does, you know, I'd really love to know.
Mm.
Air, remember, air is comburant. Air will support combustion.
Yeah.
So if air supports combustion,
Exactly. Air supports combustion.
No,
Nitrogen.
no.
Nitrogen is.
Oxygen, air with oxygen in it. Does.
Yeah. Okay. Yeah, but that's air by definition because air is a mixture of nitrogen and oxygen. And
No.
other trace
But
gases.
since the air we have on Earth.
Yeah, but are you talking about air when you're talking about the atmosphere of other planets? I don't think you would call that air.
I would.
Okay, we need a native speaker here, Jared.
Sorry, went to grab a drink.
Okay, the definition question. Would you call the atmosphere of Mars the air of Mars?
In a very colloquial sense, yes.
So let
Wow.
me just check the definition of air. Not a French band. God damn it.
Doesn't matter. I was literally just being in it.
Okay,
Yeah.
when I search on Wikipedia for air, the first link I get is atmosphere of Earth.
Alright, fair enough.
So I think it's fair to
I was
assume
literally
that
just-
air is a synonym for atmosphere of Earth.
I was literally just being a dick.
Okay, so I guess it's fair to say that the sodium reacts with the air. That's completely fine. But again, why? If they're saying it doesn't contain oxygen, then what's reacting and where does the oxygen come from in the sodium oxide?
And if you're saying
Or in the carbon dioxide, or in the carbon dioxide in the Kendall experiment, where the fuck do the oxygen atoms come from?
How are you breathing?
Yeah.
No. Not how are you breathing, but why are you still breathing?
Well,
I
that too.
actually agree with John Allen Elson in the live chat. I could use some nitrous oxide right now.
Understandable.
What are you, a fucking dentist?
It would make these two a lot more tolerable.
A few days ago, I bought a new set of drill bits for my Dremel. Apparently, 9 out of 10 non-official dentists recommend them.
Wait, for your what?
Dremel.
You just said it with a very heavy accent for some reason.
Yeah, because I think it's a German brand, isn't it, Dremel? I think.
Well, Dremel is also an actual part of machines.
Oh, it's actually an American. It's named after some person. It's the name of someone. And I thought it was it's an Austrian immigrant who lived in the US. So I guess I'm justified in pronouncing it in the correct way.
No, because the correct way would be the way Americans pronounced it.
But if the guy was Austrian, yeah, well, whatever. Okay, enough of that dentist joke.
Okay. It's got the right pressure as well. And we have to remember that oxygen is concentrated air. Oxygen's concentrated. Do you see any concentration of air in this process? I
still want to know what they mean by concentrated air.
I don't know either. It's just word salad.
Like concentrated air, the only way I can interpret that makes sense is that you compress air. I guess that's technically concentrating it, sort of.
I mean, you can concentrate gases, but they're just describing this in a so fuzzy way that I'm not sure what they actually mean or what process to concentrate air they actually propose.
Well, either way they'd be wrong.
Yep.
Yeah. Anyway, what else did we have? What else? But anyway, we replied. You should really learn to leave comments that are confluent and with the content of the video. Because at first we couldn't understand what it was talking about.
I didn't know why.
Yeah, the fact that you...
Wait, confluent? What the fuck? That's not the right word. That's not what confluent means. Confluence means that something is like covers something completely. That there aren't holes in it.
Okay, well, they said, well, we just can come to it, so let's continue.
Content of the video that you're leaving a comment on. So instead of jumping like a bullet at a gate, why not explain the purpose of your comment and how it relates to the content of the video? Then we might get somewhere.
Yeah, and then he says, you asked in the end of your video. So he should have written that.
No, I should not have written that. If you explicitly ask somebody to do that, then you should be able to assume that if somebody points something out like this, he or she is referring to your comment about that.
Like it's pretty fucking easy.
Man, seriously, what the fuck? Don't they actually... Are they unable to assume the context of a comment? Or to guess the context of a comment?
No, they're just...
You think they're just being dicks?
Yes.
They are, yeah, exactly. They are intentionally avoiding how you directly responded to what they brought up at the end of their own video.
Initially.
Yeah.
You
absolutely,
asked in the end of your video.
No,
about
maybe we should
how
have
one
read
of
this
your
comment
viewers
first.
would show that oxygen is in the air. Well, if you want to,
How does that prove that there's oxygen in there?
Yeah.
Because the reaction wouldn't happen if there isn't.
You have to repeat that, Micro, you roboted out.
Because the reaction wouldn't happen if there wasn't oxygen. Because the reaction requires oxygen.
Yes, because again, where the fuck is the oxygen coming from? First of all, the carbon dioxide that is produced in your candle experiment. And where does the oxygen come from in the experiment that I'm proposing? And that will actually work, because I know that it works because I've done similar stuff like this. Just not intentionally. I just did it to remove waste sodium. Or dispose of it. Because the cheapest way to actually get rid of it and make sure that it's safe is just to let it react.
Not explaining that proves that there's oxygen in the air.
No, he's not explaining how that proves
Yeah.
oxygen is in the air.
Yeah.
How that proves oxygen is in the air? Simple. If you repeat the experiment that you guys did with the candles and that you showed other people doing with the candles, with a material whose combustion products are not gaseous and where no large temperature differences are at play, you will see that you will get a volume reduction of your gas of 21%, which is the expected value. That just shows that the stuff is reacting with something that is in the air. By quantifying the entire thing, you can determine how much molecule-wise it is in the air. You can see that it's approximately 21 volume %. And then you can show that it's oxygen by analyzing the reaction products. For example, by showing first of all that the material that you get, the white powder, is very basic, which is quite easy to do with just a litmus test, just a pH indicator. You could, for example, if you really wanted to, you could do X-ray refraction on it, and then you will instantly see, first of all, you will be able to compare it to existing data. Or what you could also do, you could just do, for example, 17 oxygen NMR analysis. As soon as you see a peak of this pure product in 17O NMR analysis or NMR spectroscopy, you know it's oxygen. That's just two examples. And there are multiple different ways you can do it chemically. You could, for example, reverse the calcination reaction that we were talking about earlier, which is also possible, showing that if you react the stuff with carbon dioxide, you would get sodium carbonate or sodium hydrogen carbonate. Well, with CO2 only, you would only get sodium carbonate, but whatever. You can do that. Why don't you do that? So yes, the experiment I'm proposing can definitely show that it is oxygen that the sodium is reacting with.
Yep.
And you're just fucking idiots. Ding.
It's fine coming up with all your
My
chemical
comment,
formula.
My comment provides an easy way to repeat the experiment that you guys talked about, but without having to deal with some of the issues that were correctly pointed out. Those issues being the combustion product is gaseous. There are large temperature differences at play, which will result in a volume reduction after the system cools down. But you haven't demonstrated how that proves.
Oh God. Simple. You said in this video, you were discussing how this experiment shows that there's oxygen in there because you can quantify the volume reduction. I don't need to point that out again because the argument is already made in your own video. You guys have anything to add to that?
No, I just want to die at this point.
Jared?
No, just keep it going.
Let's get it over with. Rip off the band-aid.
You've not done that.
Yeah.
Sable Eagle.
This is what these guys just can't.
Kiwi, anybody there?
Oh my God, the arrogance. And the irony. I mean, seriously, what the fuck?
I mean, at least we now know. Like, I'm impressed. I didn't know you could have two person being narcissistic at the same time.
And get along.
Well, no, it's that they have some kind of shared narcissism.
Yeah, that's because they have one shared brain cell.
Yeah, it's technically a form of a hive mind.
That implies that there would have to be a mind.
Well, it also implies that there would be multiple.
Okay, right.
Which one is wearing the brain slug?
Don't insult the slug. It's the no one's. They aren't wearing the slug. The brain slug is using them as a vehicle.
The poor guy is starving.
Yes.
Anybody there?
You just can't grasp the simplicity.
Now
of
these
it.
two have a little bit of an argy-bargy as to whether they're...
Yes, regarding that, both are actually valid. If you take a look at the Wikipedia article earlier, you show that you can react sodium hydroxide with sodium again to get sodium oxide, which is, if you combine my reaction with the one that he's pointing out, that's actually the same reaction, just saying. So yeah, both reactions are valid.
Their science.
Their equations are correct.
Mine is just cancelled out, so there's one step less in there.
Oh right, yeah.
So we've put so we need to make sure the experimental design includes either a way to dry the air or enough sodium to use up all the water vapor in the air as well as the oxygen.
Yes, obviously, well, the water vapor isn't necessarily that bad of a problem because it's relatively small amounts. So you can just use the sodium in excess because more than the equivalent that you need to react with all the oxygen in the vessel, it just can't react. So either it will dry up that little bit of water vapor that's in there, or it will just sit there and do nothing.
Yeah.
So yeah, either you dry the air to make sure that it's stoichiometrically fine, or you just use sodium in excess, which is what I would do because this stuff is cheap as fuck.
Yep.
Do we? Question mark. Well, I look forward to P&P explaining how to achieve that. We don't need to explain how to achieve anything.
You don't need to... Oh, God. Okay, here's the problem. In science, you can't just say, nah, this is false, and then walk away.
That's not true.
If you think something is false, you better provide an alternative explanation that describes the phenomena at least as good or even better.
Or at least point out why. Like, at least provide evidence for why it's wrong.
Yes, but even then, it would still continue to be used until a better explanation is found.
Well, obviously, yeah, but like... Well, that depends on how wrong it's pointed out.
Okay, yes, okay. But in the situation that we are here right now, it's perfectly fine to just continue using this, because so far I haven't seen, or even they must admit that they haven't seen anything that would contradict or that would make it unpractical to use this, even if it was wrong.
It's worked out pretty fucking good so far.
Yes, as long as scientific theory is working well, even if there are some assumptions in there that we know are not completely correct, we can still use it because it still has practical application. And it's giving us somewhat accurate results. What they have to show is that what they're proposing explains anything much better, and it must have predictive capability, and it should have applications. But so far they're giving nothing of that.
How much is left?
8.5, 9 minutes.
Keep going.
Really? All we're saying is that it's our opinion that there's no oxygen in the air.
Yeah, your opinion is worth shit.
Science doesn't care about your opinions.
Yes.
Yeah, to really dumb it down for them, opinions are like assholes. Everyone has one, and they usually stay.
Yeah. Okay. So let me make this clear once.
Except everyone doesn't. There are people without an asshole.
Let me make that clear once again. How my experiment is gonna work. It will be basically the same experiment that you guys showed in your last video. The plan is to measure the reduction of volume inside the measuring cylinder to see how much of the air is actually reacting with the sodium metal. This means that I'll do basically the same experimental setup as the one that was shown. The only difference is that I'm not going to use a candle. Instead, I'm gonna use a piece of sodium. I'm not gonna place it in the same container because I don't want to react it with the fluid, with the water that we measure that we use to measure the volume difference. I'll have it in a separate container and connect the one to the measuring cylinder using tubing, which is perfectly fine as long as I know the total volume. This setup eliminates both the volume expansion problems or expansion and contradictions because there are no large temperature differences. And it will also eliminate the problem of the volume expansion because the combustion product is not gaseous, which means that this bubbling out of CO2 that you saw in one of the experiments, that will just not happen. Once the sodium has reacted as far away as possible, I will be able to measure how much gas volume was actually lost, and therefore I can pretty much show what percentage of the atmosphere is made out of this reactive gas. When that is done, I can then basically directly show that it was oxygen by the methods that I described before.
Yep.
So, in what way is that not clear?
It's very clear that it's down to being idiots, probably somewhat intentionally.
Guys, to actually demonstrate that there is, so that we know that we are wrong.
Yeah, because that's what we said at the end of the video. Show us a demonstration that we can do ourselves.
Absolutely.
That proves to us that there's oxygen in the air.
Absolutely, of course.
And these demonstrations just don't
cut it at all. Absolutely.
See, the trouble is with these people. In their mind, there's oxygen in the air.
Absolutely,
only in their mind.
Yeah. So again, let's play this video. Yeah.
Again, the arrogance and the irony. I'm pretty sure that there's no oxygen in their fucking heads. They're deprived of it, which is why they're so fucking stupid.
Yeah, they're definitely ischemic.
Isn't it called hyperoxia?
Well, ischemia would cause hypoxia.
Okay.
Ischemia is when you block off their oxygen supply by blocking off their blood supply.
Okay.
This is sodium. It's melting in heat, but I don't see any oxygen.
No, yeah.
I don't see any oxygen.
Wait, are you expecting to see the oxygen? You mean that the gas that's colorless?
Yeah, it's a colorless gas. How would you expect to see it?
Well, apparently their whole thing is if you can see it, then it's real. If you can't directly observe it with your unaided eye, then it's just theoretical.
Okay, so condensing air would actually prove to them that oxygen is a thing because condensed air is actually slightly blue because liquid oxygen is blue.
If they ever go blind, do they then become hard solids?
I'm pretty sure that those guys never got hard.
Only for each other.
There's no test for oxygen.
I know.
We've not collected any gas where we can relight.
There's no test for oxygen. Unlike all the stuff that I proposed earlier.
I mean, splint, for example.
I know what these people, because I know these people are listening to this video.
Oh, of course.
They've got one thing they can do. Simple, easy for you to do.
What's that then?
Get some sodium metal, put it in a jar, and then put some oxygen in that jar.
In the jar.
And then seal it up.
Seal it up, yeah.
And then it should oxidize.
You don't have to seal it up, you can just use air. How
No,
is
you
that
have to
hard
use-
understand?
You have to seal it up, otherwise it's totally wrong and stuff.
Okay, so the reaction of sodium with pure oxygen, that would actually be rather nasty, I assume. I haven't seen that one yet, but I guess it's rather evil.
You don't want to be playing, in general, you don't want to be playing around with pure oxygen.
No. I once saw in the first semester, one of the demonstrations that our inorganic chemistry professor used to do was light a cigar with liquid oxygen.
Nice.
One of the first things that we were told is if you're going to be working near the liquid oxygen tanks, because they do use that stuff aboard aircraft carriers.
For what?
They actually use a liquid oxygen base as part of the environmental system of the aircraft.
Okay.
This is why pilots are not allowed to wear petroleum hair products.
Oh, that's harsh. Yeah, there's a similar story I can tell. So I'm sometimes working with basically cooling traps when you need to dry a chemical, meaning you want to remove residues of solvent. One way to do it is just to put it under a vacuum. And those vacuum pumps, those actually don't like those solvent residues because they would just dissolve in the hydraulics oil that they're using, because those pumps only work this well because they work with oil. And if you actually diluted this oil with organic solvents, it would degrade very fast and you would have to replace it every few days or so. So you want to remove those gaseous, actually residues, by just freezing them out. And the way you freeze them out is before, in this line between the flask where you store your chemical and the pump, there's a cooling trap. And this cooling trap is cooled with liquid nitrogen. Now the problem is oxygen has a higher boiling point than nitrogen, which means that if there's a leak in your vacuum system and your pump pulls air, you will have a large volume stream of air going through that cooling trap. And guess what happens? Some of the oxygen starts condensing in the cooling trap, together with the frozen residues of organic solvents.
That's not good.
Oh, no.
Okay, and then guess what fucking happens when you notice that? Because at some point or another, you will have to thaw it up.
Uh-oh.
The only thing you can do is put a water bucket underneath it and then run. Because those will react, especially with something nasty like acetone or ether or what else?
God.
Ethanol, methanol, isopropanol, basically every organic liquid that isn't already completely oxidized. And those reactions are violent. So you have to be very careful with this. As soon as you see a vacuum pump that's drawing air, first of all, close it, and then make sure. No. You have to keep the pump running, but you have to close the leak. So there's usually a main valve directly in front of the vacuum of the cooling trap that you have to close. Because then you can be pretty sure that at least the leak is closed, so nothing else happens. And then remove the cooling trap. That's usually like a blue container thingy. They're called Dewar vessels. Basically, it's a glorified, one of those vacuum canister thingies that is vacuum insulated. Basically, like one of those coffee cups. I don't know the English name for them. Thermos, yeah, whatever. Then make sure if you see that blue color inside the cooling trap. Because when you see that blue color, it's in for a bad time. Now, a few minutes of this happening is not that bad because the condensation happens relatively slowly. But sometimes I ran drying reactions, reactions is the wrong word. I dried my chemicals overnight. And guess what happens in like 16 hours? It's possible that you might condense a few hundred milliliters of oxygen. Usually that doesn't happen because at one point or another, the nitrogen is gone. Basically, the temperature is slowly rising before you run into the danger of actually doing that. But it can happen. And when that happens, you're in for a fucking bad time.
Boom.
So be careful with this.
Yeah, you hear that, audience? Whenever you're doing this thing, you pretty much only do in chemistry labs. Be careful.
No, I'm talking to Peter and Peter, not the audience.
Yep, like they're gonna get a vacuum pump and a cooling trap.
Oh, come on, the stuff is not that expensive. One of those cooling lines is about $1,500, maybe.
Again, I seriously doubt they're gonna go out and get that.
No, I doubt they do it either.
I kind of hope they do now.
By the way, we call this a cooling trap system either a cooling line or it's also known as a rake because it kind of looks like one. Okay, let's continue. Fuck this.
It should form sodium oxide.
Should form sodium oxide.
Absolutely, of course, yeah.
Because the oxygen will react with the sodium.
Sodium,
Metal.
doesn't it?
Yeah.
Absolutely, of course, yeah. But let's get back, because so GeoStraber, I don't want the sodium to react with the water whatsoever.
Well,
I only want to react with the
want.
oxygen in the air.
Why isn't he doing this?
Yeah, again, if you're challenging me, I'll do it. It's no problem whatsoever for me.
Also, that is. Do they not understand basic English? Saying I don't want to in that context is perfectly fine, even if you're asking them to do it.
So are you saying that my English is better than the one of those two dumb fucks?
Apparently.
Yeah, I agree. It might be. At least when I'm writing, when I'm speaking, I'm a fucking idiot.
Ding.
Well,
Do you know what I mean?
absolutely, but how does he know there's oxygen in the air?
Yeah,
He hasn't tested for it at all.
Yeah.
This way you're going to get a good result. The air should be as dry as possible, and the experiment should be set up in such a way that there is no chance that the sodium contacts any water. For example, it would be possible to not use water but go for an unreactive liquid instead. For example, something like silicon oil. What are these guys talking about? They want...
How the fuck are they not understanding this? I'm commenting on a video where they pretty much...
They're willful.
Yes, where they pretty much exclusively talked about one set of experiments that all were performed in more or less the same way. How can they not understand this?
It's not that they can't.
It's that they don't want to.
Yeah, they have the capability. They are choosing to run with their narrative and ignore what you're actually saying.
Yep.
to demonstrate oxygen's in the air, not the properties of sodium metal. You know, I mean, going off at tangent, these guys...
That is not a tangent. That is directly relevant. Confirming to it's removing a source of error in the experiment that has something to do with oxygen.
Losing it. They're losing it.
So I'm just going to.
Well, I wouldn't solve.
No, we're not. So we're not going to reply to these guys, but you know, because we've done this video. You know, if you guys are listening, you know, please, you know, all we're asking for is a demonstration to show that there is oxygen in the air.
Okay, so that's a challenge. I'll start preparing it.
And hang on. They asked for it yet again. You have provided it. Let's actually get them to acknowledge that they do want this demonstration to actually be done.
Well, I'm pretty much that they already said it, because they said they want a demonstration. So for me, that sounds like a challenge. They acknowledge that they want somebody to actually do this.
Then do it. I want to see you do it. I want to see live. Although we will have to do something else for the couple hours. We have to wait.
Well, since I now have this awesome secondary computer, which I can pretty much take anywhere, I'm just gonna do a live stream with that. So I'm gonna pretty much drag a monitor and my entire setup to... I don't know yet where I'll do this.
Well, no, but we still have to do something else while, unless you just want to have just showing this, a picture of the reaction and nothing else.
I got an idea that I think the audience will agree with, at least a few people in the audience. Since these two have ruined our Halloween and our expectation of some beautiful playing of Doom 2, while you're giving the experiment that it's time to actually do its thing, that's what gets streamed. The gameplay.
That's a good idea as well.
That works. I'm in for that.
By the way, Jared, we still need to finish it. I think we stopped at the courtyard last time, which is map 19, right. I think. John Smith. I could do that, but I'm not gonna. In that case, I'm definitely not gonna use water.
Nope. You don't do that. Definitely not on raft. If you are gonna do it like that, at least have something that's like secured and not like floating.
But, well, it's possible to do it like this. Let's just say, if you're careful, you can set up an experiment for that, yeah.
Well, yeah, but like, why? Why would you do that?
Just so they understand that it's actually the same experiment. Maybe as soon as they see one single tube or one single secondary container, they say, no, that's not valid.
Well, that just even more demonstrates how fucking idiotic they are, so...
Stone Monkey, I was hoping Geo was going to be dressed as a mad scientist. I'm always dressed as a mad scientist.
Yeah, I was gonna say, it is Thursday, so...
Yeah, but Jared, tomorrow is a holiday over here. So, it's actually the day before the weekend for me.
Yeah, but you still had to work today, which means you were dressed as one.
No, I actually wasn't working today, but whatever.
He doesn't have a job.
Yeah, I'm in this weird phase between ending the university and starting for my dissertation.
Aren't you special?
Yeah, no, that's just annoying. Okay, let's continue.
Yeah, where we can collect that oxygen.
Definitely not water unless you like the old game of Russian roulette. The problem with those sodium-water reactions is that they're actually kind of erratic. Whether you get an explosion or just a little bit of fizzing on the surface really depends on how clean your metal surface is. The dirtier it is, usually the slower this reaction goes.
Oh yeah, dirty metal.
But I would not want to play that game. So yeah, again, be very careful with this kind of stuff.
And actually test it. It will relight a glowing splint. This is what you're failing to see. You know, it's okay people saying that there is oxygen in the air, but we need to relight that glowing splint. Then we know there is oxygen there.
Because these guys also have to bear in mind that our understanding is that oxygen is a man-made gas.
Stop. Just because you can make oxygen, and there's a very easy way to do it. All you need is potassium iodide and hydrogen peroxide. That's enough to actually produce oxygen yourself.
Well, I mean, you're not really producing the oxygen.
You're producing oxygen gas, which is what they're asking for.
No, but I think what they mean is that, like, when they say man-made, I don't think they mean getting the element out of something else. I think they mean that it's somehow actually like made from the ground up.
Oh god, but that's even more stupid than expected. 6 minutes to go. Let's do this in 1 minute increments, okay?
Okay.
I want it to be over.
The manufactured gas.
Concentrated air.
Absolutely.
That's all oxygen is. There's no oxygen in the air. You have to get the air and concentrate it.
Concentrate it, absolutely, of course.
And then you have your oxygen.
Absolutely, and because concentrated air doesn't exist naturally as a gas. It doesn't exist.
And also,
so therefore it's got to be manufactured.
And also, one thing that we have to say, and that is you've got to watch that water vapour, that moisture in the air, because alkali earth metals really dislike that moisture in the air.
Sodium is not an alkaline earth metal.
No, it's not.
Sodium is an alkaline metal. Again, different main group, different chemical properties. I don't think I actually caught that one last time.
Because that's what decomposes them.
Absolutely,
because we've done it with calcium.
We've done it with calcium as well, and they're all the same. Here's the reaction of
no, they're not all the same.
Sodium.
Calcium and sodium are two very different things.
Also, they didn't do it with calcium. The only reaction they showed with calcium was a calcination reaction.
Well, no, they said they've done it before, and they mean in a previous video, probably.
I don't think they did. I think they were talking about this stuff earlier.
Yeah, they were referring to earlier in the video when they went to calcium and magnesium stuff. You got to remember, goldfish memory.
Oh. That's an insult to goldfish.
Metal with water. Let's just mute that because we don't want this. Here we go. Very similar to
I don't want to learn anything.
lithium, potassium.
They're all
Now
the
here's,
same.
here's sodium metal kept in some kind of oil, I would imagine. Okay, so he's going to get a piece out of the jar.
If you had the sound on, you could probably hear what it's in.
Go. Slices it off. Okay.
Because you've got to think about sodium. A lot of these alkali earth metals are made through electrolysis.
It's not an alkali earth metal. It's an alkaline metal.
And it's not made through electrolysis.
You can actually make it through electrolysis. It's
Yeah,
hard,
but it's
you can do it.
almost definitely not how it's actually made.
I'm actually not sure. Let me check.
That would be a really stupid way to make it.
No, I wouldn't be surprised if it was a waste product somewhere.
Okay, well, a waste product, fair enough, but I don't think there's a big plant somewhere that it uses electrolysis to produce it.
Commercial production.
It's probably a chemical, some kind of.
Oh god, that's a nasty one. It's a carbothermal reduction. So basically, you heat the stuff up in a container with graphite, with pure carbon coal, and you get carbon monoxide and pure sodium.
See.
So yeah, that's a nasty one.
Yeah, that you have.
Oh no, wait, stop. That was done earlier. Sodium is now produced through electrolysis.
Oh, okay.
By using sodium chloride downcells.
It's probably because we now have more access to electricity and like better electronics.
Okay, basically it's a waste product of the production of sodium hydroxide.
I still think the other one sounds fun. You get an explosive metal and carbon monoxide, an invisible poison.
Okay, let's continue. 5 minutes.
Electrolysis, and which is why they dislike water, which is why they're so easily broken down with water. With water. Yeah, absolutely. Yeah, of course.
Because of the way they've been manufactured.
Absolutely, yeah. So he's just testing their
electrical conductivity.
Electrical conductivity.
Because it's a metal.
Okay, so there you go. Drop of sodium metal.
That is actually rather risky, what he's doing here.
Yeah.
First of all, I would not do this in a glass container, because if the surface would be really, really clean, it's possible to actually shatter this rather easily. Which would mean that it overflows to the second part, which is placed directly next to it, so no.
Well, I think he's removing...
Yeah, but he's removing it after putting the first one in.
That's true.
That should be done beforehand.
In water, and straight away...
Yeah. And what's released is the pressure that was used to make the metal.
Oh my fucking god! Pressure has absolutely nothing to absolutely fucking do with it. Pressure is completely irrelevant to this. What the fuck are you talking about?
Does he think the pressure is stored inside the...
That's what it sounds like? I mean, okay, so here's the reaction. The sodium metal reacts with the water to produce sodium hydroxide and hydrogen gas. And basically, the reason why this this little sphere there of sodium metal is floating on the surface is because the reaction to form hydrogen gas actually happens so quickly that there's a small layer of hydrogen gas between the two that actually keeps it up, physically keeps it up. It doesn't allow it to make contact with the water surface very much. So that's what you see here. And those whitish, flakes, I guess, of those material, that's just sodium hydroxide.
Absolutely. And there's a ball of sodium metal
Look at that ball.
rolling around. You can see the heat, what they called heat.
No, that's not heat. That's the stuff is sinking because the local concentrations of sodium hydroxide on those positions are higher than they are further down. So the density of the water is actually slightly higher there, and the refractive index is slightly different, which is why you can see this.
Coming off on the bottom there. Yeah. I've forgotten what they're called. What you get with sulfuric acid when that's added.
Wait, sulfuric acid?
So water.
Where are you getting the sulfur from?
I need to see that again. Wait a second.
He said sulfuric acid.
Okay, let's go 20 seconds back. Let's run this until 51 minutes, okay?
Pressure that was used to make the metal.
Absolutely. And there's a ball of sodium metal
Look at that ball.
rolling around. You can see the heat, what they called heat, coming off on the bottom there.
Yeah.
I've forgotten what they're called. What you get with sulfuric acid when that's added.
Oh, okay. He meant he was saying that you also get that when you mix sulfuric acid.
Yeah, okay. There are actually multiple effects going on at the same time when you dilute very concentrated sulfuric acid. First of all, obviously you have different refractive indices because of different densities. Second of all, I don't know if you've ever seen this, but if you dilute an acid, it actually turns fucking hot. So
yes.
There's
because
also,
you're getting a reaction.
Yes, you're getting a reaction. Basically, it's less energy rich for the acid to be deprotonated, which is why energy is released. So there's different materials, different temperatures slightly when you do this, and also different refractive indices, which is why you see this.
So water. Absolutely.
It doesn't like water, does it?
Yeah, it doesn't like water. It's gone. There you go. There's another piece there. And so what's forming in the water? You get hydrogen given off. But
Yay! So they accept that hydrogen is given off, at least something.
what's forming in the water is what they would say is sodium hydroxide. So what they do is they dry out this stuff, okay, and then they heat it up, or they just dry it out.
Yeah.
And you've got sodium oxide.
So basically they caught the hydrogen gas, which is lighter than the air, in this measuring cylinder and then lit it up and showed that it's combustible.
Yeah.
Just a demonstration of showing that there is a combustible gas forming in that reaction.
Yeah.
But they can't calcine it to make true sodium oxide because it melts.
Oh, right. Yeah.
No.
So it looks like they're in a catch-22 situation. And sodium
No, you just don't understand the word you're using.
Okay, so about this chemical reaction that they did, they are using a pH indicator, probably phenolphthalein, to show...
Almost definitely.
Definitely, yes. To show that this is basic. So the pH value is very high because you have tons of sodium hydroxide now in there.
Yep.
Alright, so from the live chat, Astronomy Live, these geniuses. They accused me of faking my videos of Falcon landings. I blocked them on my channel out of anger for the accusation, but I just unblocked them in hopes of more stupid entertainment.
You don't need to unblock them, you can just watch this video.
Really is a pseudo substance.
Substance, yeah.
It's a pseudo chemical substance.
Yeah.
It doesn't exist at all.
If it doesn't exist, Peter and Pete,
Then why is it there?
Also, like, they do understand that, like, pseudo doesn't means like fake.
What I was about to say,
like...
Peter and Pete, if it doesn't exist, what is Sigma Aldrich selling again?
Yeah.
And why haven't they been sued?
Because it can't exist.
Yeah.
Absolutely, of course. But
Unless it's palmed off with something else.
Unless it's palmed off with something else.
Wait,
So
that's still existing. Even if we grant you that, which is bullshit. Even if you grant you that, that's still existing.
Well, again, these are the people who denied the results of electrolysis because of the increased
Because they
power
can't do
requirement.
yeah, because they can't just plug it into the outlet in the wall.
as something
or
else.
something else is palmed off as
Like
it
sodium hydrate.
drops.
There's no such thing as sodium hydrate. What they're talking about is sodium hydride. And again, nothing to do with one another. There's no such thing as sodium hydrate. H-Y-D-A-M-H. Oh, God damn it. I'll post it in the side chat.
Sure, there is. If you add water to sodium, you get sodium hydrate. You hydrate the sodium. Stay hydrated, kids.
So the fact that they are starting to make up a word here shows that they have no fucking clue what they're talking about.
Hydrate, sodium hydrate,
yeah.
where sodium hydroxide has just been dehydrated.
Yeah.
Okay, but that would be sodium oxide and not sodium hydrate.
Also,
because that's
I love
sodium.
that they're just leaving out the fact that like they're talking about these things as if they exist, ignoring that they contain oxygen.
In the water, that white powder that falls to the bottom of that
Yeah,
beaker, that is a sodium hydrate.
But that's that I'd say that.
They have no fucking clue what they're talking about.
They're just using words now.
Yep. Complete word salad. No coherent chemical definition whatsoever.
That's sodium hydrate. So if you evaporate the water off it, you'll be left with sodium, what they'd say is sodium oxide.
Yeah.
But you would be left with a sodium hydrate, wouldn't you? That would be a sodium hydrate, wouldn't it? That would be sodium hydrate.
They have confused themselves.
They have no idea what they're talking about.
Also, I like the fact that like there's one thing when we get confused or like mess up on a live hangout, but this is like they edited this. This wasn't live stream. They could cut out their confusion.
But then the video would be only 10 seconds long.
It would just be the intro.
No, but you could.
No? I know we're just...
Oh, yeah.
Yeah, you know what I mean?
Yeah.
Yeah, absolutely, of course. But, you can't get a true sodium oxide simply because it melts. And it doesn't form that white powder that you would get.
So
Which is why I'm not suggesting heating it up. You fucking idiots, ding.
Normally with other materials that you'd form an oxide with, like calcium or magnesium or even lithium.
So get your thumbnail up.
So there we go.
And Geostreba and your PAL.
Absolutely,
Golden
of course,
Eagle.
Gold Sable Eagle. Yeah. I mean,
Sable
it's,
What?
The other guy that was commenting in that thread with you, they're
I
they're
was
conflating
thinking.
that you two are friends.
Yeah, no. I've never heard of the guy before, I think.
it's good that you're coming on the video and you're leaving comments and you're being proactive. But we'd like to see something
They clearly
that's
don't know
tangible.
They clearly don't know what's proof.
And I would like to say that
You've got to show that there's oxygen in the air.
Okay, I'm gonna do the experiment. Fine. If they want it, they can have it.
absolutely, of course,
You know.
yeah. And that means relighting that glowing splint.
Yeah. So in other words, get the oxygen.
So you
From
need
the
to
air.
get your thinking caps on, people.
Oh my fucking god.
The fucking like we need a word for like arrogant irony. Or ironic arrogance. I'm not. We need.
Dipshittery.
What about irony?
I used to be an adventurer.
Yeah, get the oxygen
Absolutely, of
from
course.
the air. Collect just
Yeah, of course, yeah.
And then just
Yeah,
relight
thanks
that
ever so
glowing
much,
stuff.
yeah.
And then you can test it. Wow, look at that.
Yeah, of
I've relit
course.
that
Well,
glowing
there you
stuff.
have it. So there you go. And you thought sodium oxide was real.
Real.
Well, it's our opinion that opinion is wrong. And
Yeah, and
that
you're
opinion
fucking
is
stupid.
wrong.
It's not wrong, it's fucking worthless. It has no practical application whatsoever. Which is why it's fucking worthless.
sodium.
I think Aaron Ra often sums up this entire thing. only accurate information has practical application. And so far, I haven't seen any accuracy of what you guys are saying, and I haven't seen any practical application. What's so funny?
So, ugly German proofs. Smogchasm?
Oh, that's not bad.
That's a good one. I like
it.
Smogchasm. Good one. I'm using that from now on.
Okay, 1 more minute. Let's just roll this all the way to the end, shall we?
Yes.
Oxide is really a pseudo substance.
Substance, absolutely.
Absolutely. Pseudo
Well,
compound.
Yeah, basically, yeah.
Pseudo
you'd agree with
substance.
that.
Absolutely, of course. So there you have it. So always remember till next time if something doesn't make sense. Like
cobalt and nickel being magnetic.
So yeah, that's something we need to talk about another time. Because they've let out a bunch of stupidity about magnetism as well in this part that we've skipped. But again, that's part for another video.
cobalt, nickel, and or gadolinium.
Gadolinium.
It's gadolinium, not gadolinium.
No.
Gadolinium as well.
Obviously contains iron, doesn't it?
Obviously contains iron.
Right.
If you thought
No.
What happened to let it running out?
Gadolinium. Oh, for fuck's sake. Gadolinium is a lanthanide. It's not an iron alloy or anything. There's no iron in there whatsoever. Only gadolinium. How the fuck do they not understand that?
There is kind of iron in there. You could break it up into if you break up the nucleus into multiple pieces, you could get iron.
Yeah, good luck with that.
anything ferromagnetic didn't contain iron.
Oh, right,
Absolutely, of course.
That'd be a good title for a video. And you thought anything that didn't contain iron was ferromagnetic?
Or, yeah, something like that. Yeah, of course. Yeah, of course. It's all rubbish, isn't it?
It's all rubbish. Absolutely.
So thanks ever so much, and we'll see you next time.
Okay.
Bye.
Ta-da.
Fuck off.
The earth isn't round, it's
Yes,
flat. How
all
do you
of
know?
what you guys have said is nonsense.
I've observed
Let's just
all
run
my
this to
travels
the
over
end.
Europe. It's flat. Everywhere it's flat.
Do we have to see this?
Oh, and to be fair, their whole thing about the whole science, if it sounds wrong, you just might be a dumbass.
They're just dumb as shit. Dumb and arrogant. And they have nothing at all to bring to the table. If there was at least a there, if they were to make one coherent point, then maybe it would be worth talking to them. But the way they behave and just a general idiocy. I mean, seriously, I'm kind of disappointed in humanity right now.
Yeah, and that's where at one point I was considering suggesting to you, when you figure out when you're going to do this, invite them to be on the panel as it's taking place.
Oh, I definitely will.
Remembered how, but then I remembered how they were on Team Skeptic's channel and how they had to be removed because of their
They were children.
Their rather offensive behavior.
They acted like 2-year-olds.
That's an insult to 2-year-olds.
Yeah, well, I don't have I can't make a comparison that won't be insulting to anyone. They were
imagine the most offensive, socially inept child that is in the body of an adult.
Your president?
They were much worse than that.
Okay, and with that, I actually have to go in a few minutes, so I'm gonna end it right here. So we're gonna do this the good old Red's rhetoric way. So Micro, say what you gotta say, and then just stay, but don't speak anymore.
The pain. The pain.
Okay, Jared.
Fascinating.
And with that, we're gonna end it right here. Thank you everybody for watching. See you next time.